Hello everyone.
Everyone, please take your seats. We're going to start now.
Guys, I'm so excited to host this for today. But before we begin, we have some fun activities for you all. I just hope you all must be on LinkedIn or Twitter. Are you all?
Yes.
Okay, this is so nice. We have essentially 4 hashtags for the event. First is hashtag ccdbhopal22. Next is hashtag GDG Cloud Bhopal. Next, hashtag ccdbhopal. And the last one is hashtag GDG Bhopal. So let's see which person gets the most likes on LinkedIn and on Twitter, alright, with posting with these 4 hashtags, whatever it is, your selfies or the venue or the decorations or anything, and let's see who gets the most likes. So start posting everyone about the event. I'm so excited, and let's see your excitement too. You can connect with the Wi-Fi there, and just in case it's not working, so we're working on it. So you can wait for a while.
यार रेड लिंक देखा मेरे को, इसका कलर टोन कैसी आ रही है? सही आ रहा है, देख लिया। ये सब ब्लिंक क्यों हो रहा है? वो पीछे का ब्लिंक, पीछे का एलईडी है, एलईडी दिखेगा तो ब्लिंक होगा। एलईडी होगा तो ब्लिंक रहेगा ना। स्पीड स्पीड ठीक है, ठीक है। नहीं चलने दें, 4 तो सॉफ्ट है। हाँ, फैन में हिलाना नहीं है। थ्री डी
Hey everyone, it's Cloud Community Days finally happening. Can we have a cheer on this? Wow, that's so cool. Well, from attending one of the CCDs myself and now finally hosting this one, I'm really excited to welcome you all.
We are so excited to be here and so honored to host you all for the day. So hi, my name is Arpita Telang.
And my name is Khushi Trivedi.
And we welcome you all to Cloud Community Day Bhopal.
Well, Google Cloud Community Day is essentially a flagship event which is brought to you by GDG Cloud Bhopal. Here, you get assistance in preparation and help in learning and exploring a whole lot of skills and interact in cloud technologies as well as Google Cloud certifications.
We have expert speakers for you today who will let you guys know how and what about the Google Cloud platform and Google Cloud certifications to help you accelerate your career by boosting all the knowledge. Cloud Community Day is powered by a shared belief that when developers come together to exchange ideas, amazing things can happen. So get ready to witness an amazing event for the day, guys.
So guys, we can't wait to start off with the event. So let me first acknowledge our eminent speakers and guests for today who belong from awesome companies, even including Google. So are you guys excited? Can you give me a cheer, please? Thank you all. It was once said by Bill Gates, the advance of technology is based on making it fit, so it becomes the part of everyday life and we really don't even notice it. On that note, let us acknowledge the presence of our speakers.
So we all know that you guys have already got the information from the speakers from the social media platforms. But let me just introduce you to all our speaker panel. So first we have Apala Singhal, Director, Cave Gemini. Then Mr. Sanchit Malhotra, Cloud Architect at Google. Next, Rohit Gumare from Solo.io. Then the fourth speaker is Ashok Vishwakarma, Google Developer Expert, and Vaibhav Malpani from Incedo Inc.
We also have Sameer Khan, Organizer GDG Bhopal, Ankit Patel, Senior DevOps Engineer at Mindtree, and of course, our organizers for today, Aditya Shah from INC Sub LLC, and of course, Mayur Rathi from he's a cloud consultant at Capgemini.
So without further ado, let me call upon the stage one of the organizer, Aditya Shah, to address you all with the opening welcoming note.
Can we have a big round of applause, guys?
Hey guys, am I audible? Yes. The mic is not working. Am I audible now? Yes. Cool. So, as already told you by our anchors, like Arpita and Khushi, I'm Aditya Shah, an organizer of this event, the Cloud Community Days, and I'm also an organizer of GDG Cloud Bhopal. I co-organize this with Mayur Rathi. He's standing there, just so you guys know. Say hi. Thanks, Mayur. So, I welcome you all to this grand event that we are hosting in Bhopal for the first time. It has been hosted across multiple cities in India through from this month and before month. Basically it was 2-month campaign, and then we are hosting here in Bhopal today. Today there are 2-3 places, 2-3 cities where this is being hosted, and Bhopal is one of them. So congratulations and thank you for coming here. A huge round of applause for you. So let me just tell you about what GDG Cloud is and why we started and why are we hosting this event. So as you all know, in Bhopal there are no tech startups, no tech companies, not big giants at least. So there are no techies also, I would say. Not really techies, but then we don't have really good professionals or professionals who work in big companies, big MNCs, or who are very good at something. Hence, we thought of just creating a community of cloud enthusiasts. By cloud enthusiast, I mean anyone who works on cloud. It may be any kind of cloud, AWS, Google Cloud, it could be DigitalOcean, it could be any kind of cloud. Everyone come together on a single platform, which is GDG Cloud Bhopal, and then talk about it. Just talk about it. You don't need to, give any session, listen to any sessions. Just talk about it, have networking, have any kind of sessions that you like. Sometimes it may also involve learning. It may also involve networking. It may also get you jobs, for example. How many of you are students? Oh, a majority. So, yeah. So my third point was for you. How to get jobs. We basically think that the only source of jobs is the college placement, right? So it's not that. It's way beyond that. Like for example, if you go by your college, what do you think the average package is? 3.5? 4.5? Well, that's nothing, right? You are made for something big. Like we are made for something big, right, Bhopal? Yes. Great. So when you do communications, when you do these kind of networking, you meet a lot of people who might be experts at something, who might be working with some good companies. And this is not only for students, this is for professionals as well, because whenever I want to switch, for example, what I'll do is, since I'm in the community, I might just forward my resume to a lot of people in the community, or will post it on my LinkedIn or wherever, or we'll just go to a meetup and ask like, do you guys have any openings? And they will just refer me. Why? Because I'm in the community, they know me so well, right? So that is how the communities benefit, and that was the whole purpose of like network with each other, network with like-minded people, create opportunities, create a culture. That was all of this that brought us. Sorry. So this is all that just provoked us to have this community in Bhopal, and that's where the community came. And from that community, we thought of organizing a grand event, and the campaign, like this Cloud Community Days, that was already being organized in multiple cities across India and across the world, basically. So this is there we are, right? So thank you for attending again. So let me just brief you about the schedule that we are going to have today. We started a bit late. I'm sorry about that. We had some technical glitch. Your internet might not be working, right? Yes. Or it should be working now. But then you don't have to use it now because, like, listen to us for some time. You can use your internet. We'll give you a chance. We'll have activities today. So let me just brief you from the scratch. So starting now, you had your tea and coffee, right? So that was a different thing. Like that's not the schedule. So the schedule starts from like the keynote thing, and now that we'll have like 3 sessions from different speakers, from different companies and different cultures. Once we have those, we'll have our lunch at 1. After that, we'll also have like 4-5 sessions again. You might have already seen the schedule. Have you? Yes. Everyone? Cool. So. And like out of these all, we don't really want only the sessions. Like this is not a college seminar, right? We might get bored just by listening to others. So what we are going to do is we will also be organizing some kind of activities for you, right? Are you guys interested in the activities, like doing something? Great. Some of you? Cool. Will do. Great. Anything else that anyone wanna ask or have issues with? No, all good? If you have anything, if you want to ask anything, if you have any concerns, we have like 0 tolerance policy for harassment and bullshit. So if you have anything like that, contact our crew. We are always there for help. Cool? I guess we are already running late, so I won't take much time. That's it from my side. Thank you so much. Thank you for attending this event and welcome.
Thank you so much, Aditya, for the wonderful and fun-loving session on the keynote. Now, guys, how is the activity going so far? Getting likes and everything on Twitter and LinkedIn? Have you guys posted? No internet? Okay. We are fixing that.
Alright, moving on to the next session. Thank you so much for the wonderful keynote, by the way. Moving on to the next session, we have Director of Capgemini, Apala Singhal. She is gonna say about how to start your cloud journey. So this is the most exciting ones for all the beginners out there. So telling much about Apala, she is a digital transformation leader. She has an extensive delivery management experience working in different niche technologies and handling big global teams. She has handled complex agile engagements, focusing on program management, activities like finances, planning, executions, and stakeholder management using different technologies. So this session is worth for you all to listen. Let's have Apala with a huge round of applause.
So guys, Apala is going to join us through virtual meetup. So like she couldn't be here in person, but there she is. Enjoy the session, guys.
Pala, you can start.
All right, I hope I'm audible. Hello, am I audible? Can someone please confirm if I'm audible? Okay, all right. Hello everyone. Estelabon Fasonda Pond. What is the meaning of it? Difficult, right? Now try to read this statement. Is it the right way to learn? Easy, isn't it? Why is it that you were not able to understand the first statement, but you were able to understand the second? That's because for the second statement, you understand the fundamentals of it, and that's why it is easy for you to understand it. Whereas for the first one,
Guys, we're working on the technical glitch there. So, did you guys get the internet access yet or not? Still not getting the internet? Which internet did you all connect to? The one with the like the credentials given there? Okay. Fine. No issues, we're working on the glitches. Really extremely sorry for the glitches over here. But basement problems, guys. Just working on the internet.
मैं इसलिए बोल रहा था 85 लगा लिया दूर से करता यहाँ पे कैसे करिए हालांकि मैं इसमें भी कर ही रहा हूँ एक दो कोई इसकी क्लैरिटी दिखा लिंक भी शेयर मेरी सबसे पहले तो यानी कैमरा पर्सन को शेयर करने के लिए पोस्ट करके दे दी भाई मैं दिखा के आ रहा हूँ मेरे को तो मालूम चले Okay, so meanwhile we get all the glitches sorted. We are going to start with one of the activity, but let us get the confirmation before if we are connected to Miss Apala or not. Hello.
Meanwhile, I just would like to give you a suggestion. You can just flaunt your ID cards. You can flaunt the decorations, the standees in your selfies and your pictures for the social media post. We also have a specially designed filter for CCD Bhopal, by the way. Its link is in the Instagram if you follow. I just want you all to follow the Instagram, LinkedIn, and Twitter handles of GDG Cloud Bhopal and GDG Bhopal. So, of course, after the Wi-Fi is all set, you all can go and have the coolest picture with the venue and everything. We have a cool filter for you.
Apala, am I audible to you?
Yes, Mayur, I can hear you.
Can you please try speaking again?
Yeah, I was able to hear you earlier as well. Can you hear me?
Okay, we can start.
Okay, I hope I'm audible, right?
So here's the session, guys. We have Apala Singhal ma'am with us.
Hello everyone. Estalabon Fasondepon. Are you able to understand it? Okay, no problem. Now try to understand this one. Is it the right way to learn? Are you able to understand this statement? Why it happened that the first statement you were not able to understand, where the second statement was very easy for you to understand? That's because the first statement is into French, and if you don't know the fundamentals of that particular language, you won't be able to understand, right? So if we want to learn anything, we need to start with the fundamental aspects of it, and then we can definitely go further and at the expert level. In the similar way, when we are talking about learning the cloud, so how to start your cloud journey, and that also we need to understand that what are different steps, the structure through which we need to learn it in the most optimized way. Hello everyone, my name is Apala Singhal. I have 21 years of IT experience. I am currently working as director in Capgemini. Prior to that, I worked with TCS, Infosys and Accenture. And I have worked on various technologies, starting with AWS, Google Cloud Platform, RPA, Blue Prism, machine learning, DevOps, etc. But this talk is more about you. So if you want to know more about me, you can definitely go and check it onto LinkedIn. So let's start with the talk today. So there are three steps which are involved if you are a beginner and if you want to go to intermediate stage. Now many of you might already be working onto Google Cloud, or some of you might be having very basic idea about cloud computing. Whatever stage you are in, there is a three-step process from coming to beginner to intermediate level. And once you reach up to intermediate level, the next thing what you need to do is that you need to have real-time project experience, and you need to do lots of hands-on activities to come to advanced level. So now let's understand that if you want to come from beginner to intermediate, what are the three steps involved? So the step one is that you need to learn the cloud computing concepts. The second step is that why organizations are using cloud computing. The very basic thing, the mistake which people used to do, they directly jump to step number 3. They choose any cloud provider services, they start learning it, and then what happens, they come across many terminologies and many concepts which they were not clear on those things, and that's where they go back, they keep coming here and there, and that's why the time to complete this learning, their entire learning journey becomes even more longer. So we will understand that what are the things which you need to understand if you want to learn it in the most optimized way. So if you are a person who has some experience onto it, but if you feel that step 2 might be useful for you, because here we will be talking more about different use cases where cloud services are implemented in organizations, then this talk is going to be useful for you as well. So let's get started with the first step, cloud computing concepts. So First of all, if you decided that you want to create any applications, what are different resources you would require? You would require computing resources like virtual machine, operating system, then you can create web servers, your application server. From the networking side, you will require resources like firewall so that unwanted traffic does not reach to your application, routers so that the traffic can be routed to the right server. You will require switches, and then you will require load balancers so that the traffic is distributed across the servers and it is not loaded across only couple of the servers. If you are working on the application, you might be having some data. Now, depending upon type of data, there are different storage options, and that's what you need to take into consideration when you are creating environment for your application development. If your application is about big data, then you will require Hadoop or any counterpart of it. You would require data warehouse, and if your application is in machine learning, then you will be using this data for training the machine learning models. So in short, you will require so many hardware components like server, networking, storage, and in order to procure this, there will be a huge cost of procurement called capital expenditure or capex. Once you have procured this all these components, then you need space to keep it. You will require electricity to run it, and also for ventilation purpose, you will require electricity and many other maintenance aspects, which is called the cost of maintenance or operational expenditure OPEX. Now consider this is the era where so many tech startups have emerged. In the last decade, 10 to 12 years, many new tech startups have emerged. Is it that 15 years back or 20 years back, people were not having good idea about startup? It was not the case. The problem was that if they wanted to set up their environment for development, it was very costly affair. Why? Because there was a huge OPEX, huge CAPEX was involved, and if those people were not able to get the funding, it was very difficult for them to go ahead and develop such application. But with the advent of cloud computing, it has become very easy. How? So the thing is that if somebody is given an option that you can get the infrastructure and you can use it as and when needed, and even you don't need any space to keep it, and also if you want to reduce maintenance overhead, which will reduce your OPEX, isn't it a great choice? And that's exactly what cloud computing provides to you. So, what is cloud computing? Let's understand that with the help of NIST definition. So, this is a big definition. So, what we will be doing? We will be breaking this big definition into small chunks so that it is easier for us to understand. So, first thing is that cloud computing is a model for enabling. Now, what is model? Model means it has got certain principles defined, and every cloud provider who is providing the services, they need to adhere to these principles. So, it can be any of the cloud provider, like it can be Azure, Microsoft Azure, or it can be AWS, it can be Google Cloud Platform. Any cloud provider, if they want to provide their services, they need to adhere to these principles. Sorry. The next aspect as part of the NIST definition of cloud computing is that you should be able to network access these resources. Network access means you can access these resources through internet. Then it is saying that there is a shared pool of configurable computing resources. It means there is a pool of resources, and depending on your requirement, you can access these resources. But once any resource is being accessed by any one user, that resource will not be used by other user. But once that resource is made released, it is not being used by any other resource, any other user. In that case, it will be made available to other users. So that is the shared pool of configurable computing resources. Now the third aspect, what it is saying, that the resources can be rapidly provisioned. Now consider the old time where you had to procure the servers and all. It used to take months, and even today it used to take days, because once you get it, you need to configure a number of things over there related to networking and all other softwares and everything, and it used to take days to actually get it into action. Whereas when you are working onto the cloud, it just takes minutes to get that provision, that particular resource, and it will start using it. So that's why it is said that if you are working on to Google, any of the cloud, the resources can be rapidly provisioned. Another important aspect is that minimal management effort. It means that when we will be going ahead with the shared responsibility model, and with that there will be a shared responsibility between the user and the cloud provider. And another last aspect is that service provider interaction. If you want to use any cloud provider service, you don't have to interact with their service provider people. You can start using it through any UI, and it will be very easy for you to go and connect and start using those services. Now there are different service models. Now the question comes that why there are various service models. Now there are different kind of users, and for different kind of use cases, which we are going to discuss in just a couple of minutes, there will be different types of requirements. For example, there might be some system administrators who want to ensure that they are configuring the virtual machine from scratch. They want to put their own choice of operating system and all those things. That's where they will be going ahead with the infrastructure as a service. Second is that there are some developers. Developers are not bothered that how the operating system is installed. They are not bothered about how the runtime environment has been created. What they are only worried about that how they want some environment where they can write the code and they can build it. So that is your platform as a service. Another one is software as a service. That is for the users who are not worried, who don't want to go for any infrastructure aspect, any maintenance aspect, writing any code. They are only thinking about I want to use a particular software and they want to use that only. So that's where it comes about software as a service. So for depending upon different types of users and their requirements, there are different service offerings, which is called cloud computing different service models. So what is that? Let's understand that in which scenario, which service model is more suitable. If you want maximum control on the virtual machine, that's where you should be going ahead with the infrastructure as a service. Then another one is scalability and availability. Scalability and availability are two non-functional requirements which are anyway, if you are using infrastructure as a service or platform as a service or software as a service, it is achievable. So that's one of the reasons we will be understanding later, that very easy to achieve when we are working onto the cloud. Next is that automatic software update. If your requirement is that you don't want to go ahead and update the softwares over there by your own, then infrastructure as a service is not your choice. Then you should be going ahead either for PaaS or for SaaS. Another thing is that you have a developer who wants to develop application, but the person does not, he doesn't want to take any headache for maintaining the virtual machine. So in that case, for him, the PaaS will be the best option. At the other hand, if there is any other user who is not at all worried about that, what the infrastructure is, how the code was built, and how are maintaining it, they are only worried about the software and the features they want to use. In that case, they should go for the SaaS. So this is a quick comparison between these services. So with that, we understood that what is cloud computing. Now, very important aspect is now that why organizations are using cloud computing. So first of all, if you are here, you are here because you want to learn cloud computing. But why do you want to learn cloud computing? Because there are organizations who have such requirements. And why organizations are using the cloud computing, that's what we are going to understand now. There are different use cases for which the cloud computing is being used by the organization. We can broadly categorize them into two categories. First is that cloud computing, cloud provider services helps you to set up your work environment in a very easy way. At the other hand, there are some non-functional requirements, and you can achieve the SLA of non-functional requirements using the cloud services in a very easy manner. So we will first talk about that, how it is easy for you to set up work environment. We talked about the startups, that why so many startups are emerging now, because with the help of cloud computing services, cloud providers which are providing, with that it is very easy for you to set up the work environment. So let's understand that how it is easy. So first is that the VM for web servers and application servers from cloud. Now suppose your requirement is that you want to create a web server or application server, and then what you will be using? You will be using infrastructure as a service. So from the Google Cloud perspective, you will be using compute engine. Now another requirement is that there is a developer who is not bothered about that, how you are setting up infrastructure, how you are doing making the runtime environment available. He is only worried about that the person wants to have some runtime environment where he can write the code. So that's where he will be using platform as a service, and app engine is an example onto the Google Cloud platform. Another use case is that if you want to use managed database. Now, what is managed database? So, suppose if consider the case of traditional computing. In the traditional computing, if you had to set up a database server, you will require any hardware for that. You will install the operating system on it. Then you will install database on it. And once it is done, then you will have to do other things, like you need to create replicas, you need to create backup, and in case of any revisions onto that database, you need to keep on updating it. So there is, and apart from that also, there are so many other maintenance issues and maintenance activities which a person has to do. A database administrator used to do if the person is doing it onto the on-premise. But if you are using the cloud, in that case, cloud provides managed databases, and they provide it both for the SQL as well as NoSQL databases. So from the GCP cloud perspective, it is Cloud SQL and Cloud Spanner are for SQL database. Data Store, Firestore, and Bigtable are for the NoSQL database. So you can very easily go and start using managed databases without worrying about its overhead part of it. Another use case is databases with specific licensing requirement. Now, when we talked about the managed databases, it comes with a particular set of some databases, and that too with a particular version of it. Now, maybe your client might be having some requirement that they want to use some other database, and if the database is there, then maybe some version is there which is not supported as part of his managed database. In that case, what you need to do, that because there is a specific database requirement which is not supported by cloud provider as part of managed services, you need to provision a virtual machine, then you need to install database on it, you need to configure the database, then you need to update database licenses as and when needed. So effectively here you are using infrastructure as a service, which is your compute engine, and on top of it you are installing all those things. Another use case is, suppose you are developing an application for analytical purpose, and for that also there are multiple server requirements of different types, because it is referring with big data. So first of all you need to store it, so you need some server with high storage capacity. On the other side, because you need to process this data, so you will require high processing power servers, right? Consider the case of traditional computing. If you had to create such environment on premises, in such case, it will be very costly affair for you, because you need to buy it, you need to procure it, and then only you need to set up, and then you need to maintain it. So its capex and opex was very high. Whereas now in case of cloud computing, it has become very easy. So you just need to pay and use. So as per usage you will have to pay, and you can use it as per your requirement. You can put it as per your storage capacity, you can put it as per your processing power requirement, you can get the servers, and you can start using it. So you can use the managed services over here, and those are BigQuery and Bigtable in the case of Google Cloud. Now coming to non-functional requirements, there are many non-functional requirements. So whenever we create any application, there are functional requirements on which people work on. But apart from that, there are many non-functional requirements also. And as an architect, when a person designs the application, the person takes care of all the aspects of non-functional requirements and ensure that SLAs, which is service level agreement, which is mentioned for each and every non-functional requirement, that is also met. And accordingly, the architect designs the application. So what are some of the very important non-functional requirements? Those are scalability, performance, security, and availability. So let's talk about all these non-functional requirements and see that how we will be able to achieve it very easily onto the cloud. So for example, there is an e-commerce application and your e-commerce application is hosted onto the cloud on multiple virtual machines. Okay, and there are consumers who are accessing, so there is some traffic which is coming to it. Now now when we talk about scalability, what is scalability? Scalability means ability to handle varying workload, but why the workload will be varying. So for example, there is a weekend or there is a Black Friday sale or there is a festival season, and so there is some sale onto that e-commerce site. So in such cases, there will be more traffic going to that e-commerce application compared to other days, normal days, right? In that case, the traffic which is coming to the application, the servers onto which the application is deployed, they might not be able to handle the additional load. So in such case, what you can do, you can set up auto scaling so that additional VMs will be spilled up, and then your traffic will be additional traffic will be handled by these additional VMs. And once that sale is gone and traffic is reduced, you can release, you can shut down the VMs, you can release them. So that's how you can easily get the scalability incorporated into your application, and you can meet SLA. Because spinning of VMs onto cloud is just, it is rapid provisioning. That's what we discussed when we about the cloud computing fundamentals. Another important aspect is the performance aspect. Now, what is performance and response time? Suppose you are a user and you are accessing any e-commerce application. You sent a request for maybe you want to know the product details, and you got the response after 1 year. And that is the pattern which is happening there all the time. Are you going to continue with that application? Definitely not, because there are other e-commerce applications in the market, and you can switch to other ones. So if your application is having this kind of performance issue, then definitely your business is going to get impacted, because your users are moving to other competitors and they are leaving your application. So performance is a very important aspect, and we need to ensure that our application is performing well. So now the question comes that how will you ensure that your application is performing well? So there are multiple ways how we can improve the performance of an application. So first one is that you can use read replicas. Now, what is read replica? So there are multiple ways to enhance. So one is the use of read replica. So what you used to do that the main database which you are having. So the main database which you are having, that's where you can send only write and update query onto the main database, and then you can create read replicas, which is replicas of the main database, and you can send these replicas to improve the performance of your application. Another way to improve performance is CDN. Now, what is CDN? CDN is Content Delivery Network. So what it does that we will understand it with the help of an example. So suppose there is an application which is hosted onto the cloud, and this cloud is in the data center in Canada. Now there are other data centers also onto the same cloud. There can be data centers in Singapore, it can be in New York, it can be in Mumbai, and now there is a user who is in Australia. He sends out a request because he wants to access this application. So the request will go to the nearest data center. So in this case, the request will go to Singapore. Now it will check whether there is any for static data, whether there is any data cached over there in Singapore data center or not. If it is not, then the request will go to the data center in Canada, and then the response will go back into the data center in Singapore. From there, the request of the client will be served, but at the same time, the data which has gone from data center in Canada to Singapore, that is going to be cached in the Singapore data center. Now, if there is another client who is also trying to access the application, for him the request will not go to the Canada data center. It will be served from the cache which we are having on the Singapore data center. So that is how you can improve the response time. Another thing is that you can improve the performance of an application using the in-memory cache. So memory store is Redis is there, memory store is from Google Cloud. So for example, there is a search query, so that will go to your main database. So what you can do, you can create a cache onto the Redis, which is temporary in cache memory, and then if there is another same search query comes, the hit will not go to your main database, it will be served from your in-memory database, which is Redis. Or if we talk about the Google Cloud, it will be memory store. So that is how you can improve the performance of an application. Now coming to the security aspect of it. So we talked about that there are different shared responsibility of security between the cloud provider and the user. Now depending upon that what service model you have selected, the responsibilities will differ. If you are using infrastructure as a service or platform as a service or SaaS, in such cases the responsibilities are going to be changed over here. Apart from that, there are three very important aspects of security. First is that when your data is moving from the browser, and use TLS. Another thing is that when the data is at rest, so Google Cloud Provide ensures that whatever data is at rest, it means data at rest means it is saved onto any of the storage or on the database. So in such case or anywhere, if it is saved, stored over there, it will always be encrypted before it is saved. It is persistent. So that is one of the very good feature of Google Cloud, what it provides, the encryption before the data is persistent. Another important aspect of security is IAM. Now, access and this is a part of access and role management. So, what you can do, you can create different roles, and for those roles, you can give different kind of access. Now, to the user, there are multiple users. Now, depending upon their role, you want to allow them certain access. For certain users, you only want to allow view access of your application. For certain users, you want to allow edit. So, in such cases, depending upon their role, you can allow different kind of access to users. Apart from that, there is very important aspect over there, which is about availability. Now consider a case that there is an application which is running, and it can be running onto the on-premises or it can be onto the cloud. Now when the user tries to access it, the request will go to load balancer, and from there the request will go to the main side. Now consider there is some problem at main side, and entire main side is down. In that case, your application will not be available, and any user from any part of the world, if they are accessing the application, your application will be down. But definitely this is not the scenario what we want. We want that all the time my application should be up and running. So how should we achieve it? In that case, what we do, we create a disaster recovery or backup site. Now, depending upon the SLA of availability, we define that what kind of setup we need to create on the DR side. And then in case of disaster, the request will be routed from load balancer instead of main side to the disaster recovery side. So this is how we can achieve the high availability. And this helps us to ensure the business continuity, and also it helps us to increase the uptime of my application. Another aspect of another use case of this cloud computing is production scale testing. Now there are you must be knowing that whenever we create any application, it goes through multiple rounds of testing, right? And then it is deployed onto production environment. Now what happens that on the production environment, multiple servers are there and lots of traffic is coming and all. But when we perform the testing over there, testing is not performed with the same load with which the real traffic is coming into production. Why is it so? Because if we want to test it at that level, it will be very costly setup for us. But now with the help of cloud computing, we can create a similar environment as we are having onto the production like environment we can create for testing. We can test it, and once done, we can release all the resources. So that will be a very cost-effective way of production scale testing. Now we are done with step 2. So it means we first understood the cloud computing concept, then we understood that what are different use cases, how and why organizations are using cloud computing. Now the third step is that you need to choose that which cloud provider you want to go for. For example, you have selected Google Cloud. Now if you want to learn Google Cloud, how you should be learning it now? First thing is that whatever services your Google Cloud is providing, you need to categorize them under different categories, like whether those services are related to networking or they are related to compute or data storage or data processing or data warehouse, or what exactly that service lies in. So identify the category. Then the second aspect, which is mostly missed by most of the people, that map the services with the use case. As the step 2, we learned various use cases where in which the cloud computing is implemented by the organization. Now when you learn these services, try to map that this particular service is going to be mapped use case, and with the help of use cases, and that's where you will be understanding what is the usage of a service. And once you are done with that, you need to perform hands-on activities. You can start with quick labs, but then I would suggest that don't stop at quick labs, because quick labs is a simulated environment. It means that particular lab is to perform certain activity, but when you perform that activity, there are multiple settings which are done at the backend side, and you won't be able to do if you perform the same steps on the real-time environment, it will not work, because the backend settings which are done, you don't know about it. So I will suggest that first go ahead with the quick labs, get the understanding, and then move to the Google Cloud environment, because Google Cloud provide you some free time access also for certain time. So that's where you can use it. You can start using it through console or through Cloud Shell, and that's how you should be learning it. And with that, if you learn, your journey will be very short and it will be very crisp, and you will be able to understand. Now that is done. Now next thing is that there are multiple roles related to cloud into our IT organization. So what are those roles? So those are cloud infrastructure administrator, cloud developer, cloud solution architect, cloud data engineer, security consultant, and machine learning engineer. Now depending upon what is your aspiration, you need to choose that what is your role which you want to perform maybe after a couple of years. And in that case, there are multiple certifications available by Google Cloud, and you can target that certification. So that is how you should plan your career if you want to go into that. And even if you want to start your own startup, we discussed that how you can leverage cloud if you want to start your own startup. So with that, I would like to close this talk, and I hope you have got a good understanding about different use cases, how you should be learning the cloud in the shortest way and in the most efficient way. So keep learning, and all the best for your future. Thank you.
This was the wonderful session by the director of Capgemini. We have another session which is going to be damn interesting, guys. So, can I have a cheer if it was interesting for you, the previous session? Thank you all. Now, just a reminder, please keep sharing and tagging us and the hashtags. Well, without further ado, we have our next speaker, Sanjit Malhotra, who is a cloud architect at Google. So a huge round of applause for his session, guys. Over to you, sir.
Hi everyone. Now I would need your attention, please. So today, we are going to talk on evolution of data platforms, how it has evolved from databases to data lakes and big data, right? Now, on the face of it, it might be, sounding a little bit more, difficult at this point of time, but I'll make sure, I'll keep it, I'll gradually increase, the level so that everyone can, participate. All right, before starting, a little bit about myself. So my name is Sanchit and I'm working as a cloud architect at Google. I am a data and analytics specialist. I am a tech enthusiast. You can talk to me about, anything and everything about technology, latest and greatest, the technologies that are there. Talk to me about data, SQL, Terraform. Talk to me about certifications. Talk to me about upskilling, right? Anything that you want to know about, I'll be there, and I'll be looking forward to interact with you guys, right? You can connect with me on LinkedIn as well as Twitter, right? So let's stay in touch beyond this as well. All right. Before we begin, an important disclaimer: all the thoughts that are there, those belongs to me, and those are not in any way, linked to any of the organizations that I'm associated with, right? Cool. So before we begin, what are the latest, trends in data that we are seeing right now, right? So to start off with, the big data industry, right? It is set to reach almost $103 billion by 2023, which is, by end of next year, right? So, but why is this industry growing so much, right? What are the factors which are influencing or which are contributing to this growth? So there are largely two. One is the number of IoT devices that are there, and they are increasingly, each and every device that you see, nowadays is connected to internet. It is either consuming data or generating data, right? So the number of IoT devices, it is set to rise by 41.6 billion devices by 2025. That's the rough estimate that the industry has come out of. The second most influencing factor is the internet users, you, me, all of us, are generating a lot of data, right? So you all are trying to go onto LinkedIn and trying to post anything and everything today, right? With all the 4 hashtags that have been given. So all of that also counts to the amount of data that is being generated, and some organizations in the world would be processing them right away, maybe in near real time or maybe in batch, right? So that is also contributing to the growth of data and hence the growth of the big data industry, right? Now, coming towards the organizations, right? Now, nearly 95% of organizations are, believe it or not, it's true that they are finding it hard to manage the data in a proper way, right? Consider the scale of the data. Organizations like, I would also talk about Google. There are organizations like Meta, and your Instagrams and Facebooks, all these under Meta, right? And Amazon, right? So all of them have been evolving their data platforms, month by month, year by year, right? That is because these organizations also need to evolve as the volume of data is evolving, right? So there is a need to manage the data properly, and that is the challenge which is faced by almost 95% of the organizations. Now, out of all the organizations, since there is a huge data that is being collected, so you need to figure out what is the value out of data that they could generate, right? Data without any value is just junk, right? So 97.2% of organizations they need to generate insights out of data, right? So they are they are currently and are going to invest more into big data, AI, and ML, right? To build the entire infrastructure, the entire pipeline, and converting raw data into insights, right? Yeah. Sure. All right. I hope it's better now. Cool. So, all in all, what are the predictions of how much data everyone and anyone and everyone is going to generate, right? So, the entire world, it is estimated that roughly around 181 zettabytes, right? I don't know what zettabyte is, 10 to the power what, but it surely sounds a big number, right? So almost 181 zettabytes of data would be generated by 2025, right? Now all these trends are good enough, but what do we do with these trends, right? Where did it begin from and where are we now? So I'll move on to where it all started from. So just to give you a little bit glimpse of what the history has been, right? So you all must be familiar with databases, right? So databases, it evolved alongside the data modeling in the 1960s, right? So the initial databases that came out, those were object-oriented databases, because at that time there were not a much understanding of multi-tables and having relations between tables. So it was all object-oriented databases. It is almost similar to what an object-oriented programming is, right? You handle classes and you handle objects, right? Similarly, it was the object-oriented databases which paved the way for what databases are today, right? So from 1960s, these have evolved from being historically relational. You've always worked, most of you would have worked on relational databases, but a lot of you must have also been working on non-relational databases, right? These are NoSQL based databases, right? Also, the way the databases are used, the semantics of how you use databases and how you segregate your data, that has also given rise to what we know as graph databases, right? I'll not go much deeper into what all these databases are. I'm just giving you pointers so that you can explore them later, right? And then today, all these databases, relational databases, non-relational databases, graph databases, right? All of these are, provided to end users and customers as managed service, right? So there's no database management, no database administrators required anymore, right? It's all handled by the CSPs, right? CSPs like GCP, AWS, Azure, and so on and so forth, right? So that's what the databases have been. So what are the databases available on GCP, right? As I talked about, three broad categories. It would be relational databases, it would be non-relational databases, and memory stores, right? Or in-memory databases. So relational databases are majorly three: Cloud SQL, Alloy DB, and Cloud Spanner. Now Cloud SQL gives you MySQL, MS SQL based workloads, right? And it's again mostly it is managed service, right? Now the new service that has come up is Alloy DB. Earlier PostgreSQL, or still PostgreSQL, is supported by Cloud SQL, but GCP has developed a new standalone service for PostgreSQL because there are a lot of stored procedures and everything that is different from how you handle MySQL and MS SQL. That's why there's a new service called Alloy DB specifically for PostgreSQL workloads, right? And then you have Cloud Spanner. It is one of the most interesting service within GCP. It lets you scale your databases horizontally, right? Not many have been able to achieve horizontal scalable databases, right? But then in GCP you have an offering wherein you can scale your databases globally, right? You don't have to worry about sharding, partitioning, nothing, right? It's all handled by cloud service, cloud spanner as a managed service. All right, moving towards non-relational. Now, these are majorly two. One is cloud big table, that is, a NoSQL database, but it is meant, for your analytical and operational workloads, right? It's an OLAP heavy database. And then you have Firestore. It's an OLTP heavy, offering, which is highly scalable for applications which run on web, which run on mobile, right, and portable devices, right? So that's what Firestore is. And then we have the last one, which is, when anyone and everyone talks about performance optimization, right, you think about cache, right, or cache, right? So memory store is one such offering which gives you both Redis and Memcache D as a managed service, right? So based on your choice, you can have the cache of your choice. All right, moving ahead. So OLTP, right? All of you would be knowing what OLTP is, right? All the traditional databases which were meant for write-heavy performances, small scale write-heavy performances, right? So all your let's say your POS systems, right? Whenever you swipe a card, a transaction is generated. I'm not talking about the financial transaction, but in terms of business, a transaction is done, right? So those transactions, all of those go and sit into your OLTP system, right? Now these are meant for writes. These are not meant for heavy reads or batch reads, right? So to handle those problems, why do you need heavy reads, right? You need heavy reads for basically doing analysis on large amount of data, right? So to overcome that challenge, we came up with, not we, as in not me, but great gurus came up with OLAP systems, which is nothing but your analytical heavy workloads, right? Or how you would know it is data warehouses. So data warehouse is an OLAP based systems, right? So these are meant to handle large volumes of data and complex queries, right? Now, once we move to OLAP, right, what are the offerings which are there on GCP, right? There's one major offering, and that is, I can surely say it is the best offering. That is, I move quickly to BigQuery, right? That's a data warehouse solution by GCP. Again, it's a managed service, right? I have brought along, what all the features are, what the benefits are, right? So we'll talk about them. Firstly, it's a fully managed serverless and clusterless service, right? So you don't have to manage clusters which you would typically do in a traditional warehouse, right? So you have to manage all the three tiers: your storage tier, your compute tier, and your the analytical and security layer as well. But that is not the case when you're working with BigQuery, right? The service is always reliable as all other services are. There's an SLA bound to the offerings with the GCP. Talking about the performance, again, the performance is reliable. The performance, there are certain benchmarks which you can find on the internet in the documentation as well, as to around how how you can predict performance. And if anyone has worked with BigQuery, it also shows you whatever queries you run, how much data was processed and in how much time, right? So you can definitely pre-predict performance of your workloads before moving into production. Then there is inbuilt ML, right? It's called BQML. It is a SQL-based ML model, right? So you can very easily learn and try to build ML models just by SQL commands, right? So it's that easy, and all the basic algorithms, right? All the basic regressions, KNNs, everything is supported by your BQML. Then talking about very quickly about the security aspects, as you know, these are very important, and these lay the foundations for the other service that we are going to talk about, which is again a new offering by GCP, which is BigLake, right? So please understand about these as well. So there's encryption. Again, it's enabled by default in almost all the services in GCP. Then you have dynamic data masking, right? You can mask PII information, whatever levels of information you identify, you can mask them, right? And then you have row level and column level security, right? Now this is very important because let's say you are maintaining a central database, right, which comprises of transactions of global users, right? And you want to give permissions to analysts of only a certain geography, right? There are a lot of compliance and regulations which restricts you to share access to data outside of a specific region or outside of a specific department, right? So you can implement individual row level and column level security as well, right? I'll show you later on, but all in all, these are the benefits which BigQuery provides, right? But if you want to use BigQuery right now, right, you have to upload all your data into BigQuery, right? Now the storage and your compute, these are tightly coupled, right? And there's a petabit network which is established between these two, right? So all your storage has to be with BigQuery, right? So that's again, you can say one advantage, but it is also kind of now becoming a disadvantage because you have to maintain multiple copies of data, right? If you have some data and you want to run BigQuery on top of that, or you want to do analysis, you have to move that data into BigQuery, right? All right. Then came the data lakes. Is there anyone familiar with data lakes? What data lakes are? No, don't worry. All right. So just to recap, we moved from databases, we moved to data warehouses. Now we are into data lakes, right? Now data lake is nothing but it gives you a storage platform to so that you are not only restricted with fully structured data or heavily structured data, but organizations now also have unstructured data, right? All your tweets that you would be doing, all the posts that you would be doing, the photos that you would be posting, right? All of that is unstructured data, right? So organizations need to analyze these as well, right? So then came the concept of data lake. Within data lake, it's largely on cloud, it's driven by your cloud storage, right? So on AWS, it is majorly driven by S3. On Azure, it is majorly driven by ADLS, Gen 1 and Gen 2. And in GCP, it's majorly driven by your GCS, right, which is Google Cloud Storage. So what was the need of data lake and what does it provide? As I said, right, it's a central storage where you can dump all your data. It can either be your structured data, semi-structured data, or unstructured data, right? And then how do you use data out of data lake, right? Now the complexity begins, right? You just have a pool of data, right? But in order to derive value out of that or do some analysis on that data, you would still need to move it to a certain system, right? Either you would have to move it into BigQuery if you want to use GCP service, or you would have to create a Dataproc cluster or a big data Hadoop cluster, right? And then move that data into that cluster, distribute them over the nodes, right? And then analyze them, right? So that is one fundamental advantage and a disadvantage with data lake, that it's a good storage space, but there's no there's no compute attached to it, right? You would still have to move your data to closer to your compute, right? So just to give you can you move to the next slide? All right. So now this is the a good architecture diagram of how you can begin creating data lake on GCP. Right. Again, as you can see, there's the central part, which is the data lake, which is in purple. Right. That's all that is the data lake. Right. Now within data lake, you can have multiple layers to structure, to place your data. Right. But then for you to be able to refine the data or generate value out of that data, you would still have to move that data either into your big table or spanner, or if you want to run complex queries on top of that, you would have to move it into BigQuery, right? Or you can have connectors, right, which would again pull data from data lake into your whatever the database is, data marts, right? And it's kind of difficult, right? If, for example, let's say you are a huge organization, right, and you have petabytes of data, it would be difficult to move data and then manage multiple copies of data, right? Because one copy of data would be sitting in cloud storage, one copy of data would be sitting in BigQuery, one copy of data would be sitting into your Hadoop clusters, right? So managing this data would be very difficult. Plus, it's very difficult to have data management and governance built on top of it, right? How do you manage security if your data, the same data is lying at multiple places, right? If you secure one place, the person can go around and access data in the second place, right? So all of these are challenges with working with data lakes, right? Next slide, please. All right. So as you understood, right, and based on my experience, I can tell that most organizations are using a combination of all of these, right? They are using databases, they are using data warehouses, they are using data lakes, right? But what next, right? You have seen, right, there are challenges with each and every offering, right? But and as the data evolves, right, and as the volume, veracity, right, these increases, right, there has to be a need of the next generation of data platform, right? So again, just recapping what the problems that are being faced by the enterprises today, right? As I said, there would be duplicacy of data if you manage the data in data lake, right? And then for querying or analytics, you have to move it to, let's say, BigQuery, right, or your Hadoop cluster. There would be data duplicacy, right? There are security challenges. As I said, if you secure it at one place, right, the person can go, backdoor and access your data in the second place where you have moved the data, right? Now, as we learned about CAPEX and OPEX, right? Now, if you maintain multiple clusters, multiple services, there is cost attached to it, right? So if you have your data in GCS, there is GCS cost, right? And then if you have to move it to BigQuery or to databases, again, there's a network cost, plus there's a storage cost at the destination service as well, right? So a lot of costs involved, and with a lot of operational overheads attached to all of these, right? Multiple services, you would have to manage multiple sources, systems, destination systems, and the pipelines as well, right? So what is the solution? Can anyone think of a solution based on what you have understood from now, that how can we solve these challenges? You have databases, you have data warehouses, you have data lakes, right? But all of them are with disparate storage, right? So how do you solve this problem? Anyone? Just a wild guess. Yeah.
So what we need to do is we need to bring all data one place and we can access it anywhere.
Absolutely correct. You got the gist of it. Clappings. Manage multiple copies, move that data onto your Hadoop cluster, right? So the need is to unify both data lake and data warehouses, right? So I'll be talking in terms of GCP. So we'll be kind of just to bring that into notice that it is not only limited to GCP, but you can cross unify as well. For example, if you have your data in S3 and you want to run complex queries through BigQuery, you would still be able to do it, right? And that is possible. So the idea is to apply similar data structures and your data management capabilities, which are already available in BigQuery, right, to data that is persisting in your big lake or in your data lake, right? So in short, what we want to do is we want to merge BigQuery and data lake, right? So that's the service now. With GCP helps you achieve that and helps you achieve that efficiently and effectively. That is big lake, right? So big lake is there's a concept called lakehouse. I don't want to go deep into what lakehouse is, but it is essentially unifications of data lake and data warehouse, right? So it helps you. It's a storage engine which helps you, unify data warehouses and data lakes, right? It helps you implement, open lake house architecture, as I told you, right on top of what you already have in your environment, right? It helps you reduce cost as we are using storage in terms of GCS, right? So it's already very cheap, right? And it scales more efficiently because the scaling of BigQuery, if you remember, that applies here as well, right? Now, what all source systems and what kind of file formats are supported, right? So it's good that it extends to multi-clouds environments. So it's not only limited to if you have your data persisting in GCS. If you have your data in S3 or if you have your data in ADLS Gen 2, which is Azure Data Lake storage, it would still be able to work, right? And it brings all these capabilities to all the open file formats. CSV, JSON, Parquet, Avro, ORC, right? All these file systems are supported. So if you have your data in any of these formats in any of the data lake, you can query it using BigQuery, right? It's now becoming that simple. So this is the overall architecture, right? Earlier what used to exist is just this left corner where you had BigQuery managed storage and BigQuery managed compute, right? And those were linked with petabit network, right? But now you have everything else as well, and that is what is Big Lake now. So all in all, it supports GCS, as well as your AWS, Azure data lakes as well, right? All the open file formats as I talked about, all of these are supported, right? And there's a service called BigQuery Omni, which it differentiates control panel and data panel, right? There are majorly two planes, data plane and control plane. So control plane still resides in GCP, but data plane now moves to, with the help of BigQuery Omni, it moves to AWS or Azure or any other data lake as well, right? So this is on a very high level the architecture diagram, right? I'll leave you to it to understand a little bit more, and obviously these slides would be shared, so you can deep dive into it. And if you have any queries or you want to learn more, please feel free to reach out to me. Now, another important topic before we kind of close it down is the security, okay? Because security is the most important aspect whenever you are dealing with data, right? Data could be sensitive, data could have PII, right? PSI, all these kind of information. So all the organizations, before they try out any service, they are very keen to learn about the security aspects of it, right? So as you can see, there are on a very high level, there are two parties involved into all of this big lake structure. One is your data lake administrators, and the second is your data warehouse administrators, right? As we said, we are unifying both of these, though these still persist independently, right? Because you can have compute in BigQuery and you can have storage in AWS, right? You can't manage both of these with the single IAM service, right? So the data lake administrators, what these the responsibility of a data lake administrator is to grant read privileges on all the connections that are originating from BigQuery, right? That's the responsibility of data lake administrator. And then we have data warehouse administrator. It is responsible to initiate the connection, right? And then once the connection is established and that connection is able to read data from data lake, then you give the access to big lake to the data analyst, right? And then they'll be able to seamlessly query data from your big lake, right? So moving on to the last slide, that is the benefits. What benefits does this unlock, right? So I have tried to break these into four major buckets. One is the interoperability between your data lakes and data warehouses, right? So the benefit, there is always a single copy of data which lies in your data lake, right? You don't have to move it into BigQuery or your data warehouse, right? There is no, since you are maintaining only one copy, so you do not need to handle multiple ETL pipelines to move your data between two systems. There is unified security, governance, and data management. So whatever, since there is a single copy, so it's easier to manage the data, manage security, manage governance, right? So you can extend the capabilities of BigQuery now. So all that data masking capabilities, row level security, column level security, all that comes with Big Lake, right? The third one is the support for multi-cloud data lakes. As I said, GCS, S3, ADLS Gen 2, all of these are supported, right? So you can now, there's a inbuilt support of multi-cloud data lakes. And the last one, the interoperability between AI and analytics. As I said, right, BigQuery has BQML, so you can write ML models using plain SQL queries, right? So now you can actually, run ML models on GCP while your data resides in, either GCS or Azure or AWS, right? So these are the major high-level, benefits that are unlocked with Big Lake, right? And I guess with that, I would like to close the talk today. Any questions? Any questions from anyone? However dumb they may be, that's fine. Yeah.
I didn't really understand the concept of data lake exactly. Like, why is it needed and what is it?
Okay, so if you have, let's say, images, how do you analyze them? Where do you put those?
Like you put it on a database and then you can just check the data.
Are the databases really optimized towards blob? Sorry, you said you would put them into databases, right? Are the databases truly optimized to handle blob? You would put it into blobs, right? How would you put an image into database? See, modern day databases, they work on the concept of tables, which is your structured data, right? And you have to build relations between them. So how do you, first of all, how do you put audio, video, photos into database? And even if you are able to put them, how do you build relationships between them? Which image is tied to which tag, right? Which hashtag? Who is the author? How do you manage those relationships? It's difficult, right? Now consider documents, consider large files. You must be building your college reports, right? Sometimes your final year reports may run into MBs, maybe GBs, if you have all the screenshots and everything, right? So how do you put them into databases? Those are not optimized to handle blocks, right? So that's why there's a need to have a kind of a storage which handles not only structured data, but it also handles unstructured data, right? So data lake, essentially the underlying storage is object storage, right? So you need to understand what object storage is. Object storage is optimized to to handle blobs. Blobs are nothing but anything that you can put in as an object, right? An object may be your image, your videos, your documents, even your CSV files or your database dumps as well, right? So it is able to handle all of these. That's why there's a need of data lake, right? But with data lake, again, data resides, but there's no compute, right? So you would still need some compute in terms of BigQuery or Hadoop cluster to do analysis on data, right? So that's why BigQuery or data warehouses are required, and that's why we are trying to merge them, right? Understood? Cool. Any other questions? Yeah.
Good afternoon, sir. So we can see that Google uses this algorithm particularly, like in Google for storing photos in the drive and for storing photos as Google Photos. So in Google Photos we get an unlimited storage, but in the case of the drive we don't get an unlimited storage. So how it actually keeps the track of all the data in the photos?
Alright. So if I'm not wrong, Google Photos does not provide unlimited data.
But they reduce the size and they provide much more, I guess.
Yeah, that's also now is counted towards 15 GB that you get.
15 GB.
Right? Suppose that you would have to buy storage.
So basically, how can they optimize the cost? Because many people want to use the service, and why exactly are they charging for it? Like the extra cloud storage.
So I might not be the right person to give you answers into what is the costing strategy of different services of Google, right? But again, the challenge is the volume of data, right? Right?
So the data are stored in the data warehouses, and you need large amount of warehouses for this.
So it's not called data warehouse; it's called a data center, right? So on GCP, if you see, there are regions and then there are zones, right? It's divided into that, right? So each zone is a kind of a data center, right? And each region has multiple data centers, multiple zones, and multiple zones have multiple data centers, right? So the infrastructure that GCP is providing you is kind of same what GCP uses for its in-house services as well. right? So all the services which have billion users already, and which are being, they are aiming for the next billion users, right? All these, so all the infrastructure that you get as a part of GCP, those are tried and tested with, all the Google services that are running there. I hope I was able to answer your question, but I would definitely not be able to answer what the pricing strategy is. Okay. Any further questions? Yeah?
So you mentioned we required a data lake to be able to store unstructured data, right?
Yeah.
But then isn't GCS already doing the same thing?
So that's what I told, right?
Yeah.
Data lake is, so the storage component of data lake is always object storage.
Right.
Object storage is GCS, but you can't do anything purely with GCS, right? There are a lot of other nitty-gritties about data lake which I did not mention. That all of that is handled by GCS, but you need to have proper layers within GCS, proper tiering in GCS, right? Once you do that, then it is called a data lake. Otherwise, it's just plain blob storage.
Right. So underneath it's just object storage.
Correct.
Right? Yeah. But BigQuery also provides a compute as well as a storage component, right?
Correct.
So when we are talking about big lake, essentially we're trying to just combine GCS as well as compute, which is already there in BigQuery. So how do you like?
No. So in BigQuery, whatever storage you have, that is not necessarily object storage.
Okay.
It's BigQuery managed storage, right? And you can only upload structured data into BigQuery. You can't query images straight away, right? And that querying images, videos is still not possible with Lakehouse as well, because it's not structured. You can query anything that is structured, right? So first you will have to kind of break down your images into, let's say pixels, or you have to convert that unstructured data into a kind of a structured data. Then only you can perform analytics on top of it. Cool. Okay. Anything else?
Hello, sir.
Yeah.
How many data centers are there?
I don't know the numbers as of now. I don't really.
Can you tell the major?
Every region. So there are. Again, I don't want to quote wrong numbers, but there's a page on GCP which tells you how many regions are there, right? Within each region, I can tell you major regions. For example, within India there are two regions. One is Bombay and one is Delhi, right? So all of these have a specific nomenclature, which I think in India is Asia Southeast 1 or Southeast 2, right? That's what Mumbai and Delhi data centers are, right? But within, so to you, it appears that it's, Delhi as one zone, right? But within, one region, right? But within that region, there are multiple zones, right? And each of these zones might as well be different data centers. Different data centers mean different buildings, infrastructures, right? So there's a huge amount of list. Regions may be around 70, 80 all over the world, and zones may be around 200, 300, but I'm not sure about the the correct number at this point.
Okay. Just a weird question, but what will happen if we nuke all of the data centers?
What will happen
if we will nuke all the data centers?
Sorry, I could not understand.
We will nuke.
Acha, nuke. Okay. So that's what high availability is, right? When you design, you have to take advantage of the high availability capabilities which GCP provide, right? So for example, you are building a, let's say, a video calling service, right? So you can't have your data and servers only residing in a single region, right? So you have to build your application in such a way that your data is replicated across globe, right? It is residing close to where your end users are or your consumers are, right? For example, if you have your data in Delhi and your application users are based out of US, there is a lot of latency, right? So you need to manage that, what the data residency is going to be, right? What regions you want to choose. So there's a whole, like I'm a cloud architect, right? That's what my job is. whenever a customer comes and they say that we want to design this. So what is the best possible design or the architecture of putting that onto cloud, right? So it's a complete new, a very broad topic to discuss. Maybe some next time, right? All right. Thank you so much.
Thank you so much, Sanchit, for an informative session on Cloud Data Warehouse and BigQuery and Big Lake. A big round of applause for Sanchit, guys.
I can see a good amount of interaction here. Let's have a good amount of interaction on our virtual platforms as well. Who all have started posting on Twitter or LinkedIn or Instagram? Can I see the hands? That's pretty cool, but we want almost everyone. Can we have hashtag ccdbhopal22 to trend on LinkedIn and Twitter? Is it possible, guys? Give me a cheer, please. Alright, so please, keep posting and please liking all the posts. And another reminder, we have a special Instagram, filter with us. Post the coolest selfies or coolest, photos that you can, and there's a surprise at the end of the day. So keep posting and tagging us as well. Alright, now we move on to the next speaker session.
Okay, so our next speaker is Rohit Ghumare. So Rohit is a developer advocate at solo.io and founder at KeepUp. Rohit is from Mumbai, Maharashtra. He has an amazing knowledge on DevOps, data science, machine learning. He is going to tell us about his machine learning story and his commendable career change retaining development and operation knowledge. So guys, I would like to call up on the stage Rohit Ghumare. Please give a big round of cheer.
Sorry for confusion. So, hello Bhopal. Yes, sir. So everyone is comfortable with Hindi, right? So I will give some examples in between with Hindi little bit. So I'm Otaku. So sorry for that. Another thing is I'm developer advocate at solo.io. So talking about myself, so if you want to ask anything about the DevRel and DevOps, MLOps and community buildings, so anything you can ask. So you can see like I have 3 communities. So it is going on around like keep up on LinkedIn and DevOps community on Twitter. So I am also contributing to open source. I am promoting the open source and how can you find the remote jobs. So nowadays quite everyone likes to work at the like US companies and staying in India. So you can see like my company is also in the US, so I do the same. Another thing is these are Twitter handles. You can go to the Twitter handles and follow me if you want, or text me if you have any doubts and all. So LinkedIn and portfolios are offered. So service mesh but without sidecar on top of Chiki. I know like sab upar se gaya. So what is sidecar? Anyone know? अरे sidecar. So similarly, in service mesh there is a sidecar. So what is that? We will decide, and how can we take the rid of that? So we can write only by. We will left it out side by side. So yeah, before service mesh, so we will go with the history of the service mesh and then service mesh and then sidecar. So before service mesh, there was like we have to connect the services manually, and there was things, but we can't add the add-ons to that, and we can't add the resources to that. So there was really big of means like we can do the things, but there was like we can't apply the business logic and what we want to get the cost of out of it, and all things were not possible easily. So that's why there was a picture and it came to the service mesh. So as I told, like there is a really long thing, so you can't go with the similarly parallelly with both of the things. So that's why service mesh was introduced, and you can see like service mesh creates the parallel between the both of them. It creates the 2 layers. One is the operation code and business logic. So it is saying like do your work, and then another thing is like you can customize it around your kind of things. So like you want to do something around that, like you want to create some cluster or create some application Yeah, so we talked. Hello. So we talked about what is before the service mesh history and now what is the service mesh and all. So it will provide you various things like you can add the resources and you can do the things which is like you can add the it's like whenever you are creating something like if you know there is a cluster or there is pods and application pods like kind of a thing. So it is something like you are building any application and for that you are like if you want to run it on multiple websites and also Google, if you try to like anytime you go to the google.com, so it is never lagging. So sometimes it happens, but why it happens? So there is some lag, right, downtime kind of thing. So that's why these things which we add, if you want everywhere. So in service mesh, if previously there was microservices, so there was some challenges. But service mesh allows it easily. But how? Like this. So there are platform goals which we can consider. So every service meshes and everything works on the two type of layers. So if you know the OSI models, so in your college there is a networking subject if you attend. So there is a layer 4 and layer 7 policies.
Yes.
So inside that one is the application and another is your transport layer. So this everything depends on that only. So we will talk morely around this networking only. So as you know, notice here is the application level routing. So this what is application level routing? So if you want to go through the service meshes, it provides you the connectivity between your application and whatever you want to build. So how you can connect and how you can do the same, it is related to this. So it will also allow you to like customize it. It will allow you to filter it. It will allow you to transform it to a new type of a system. Like if you are working on something and you want to install new, so it will. Thing is like Istio will restart. So how to not restart, we will talk in the afterwards. But Istio is the thing which will restart whenever you add in something. So another thing is observability. So like you know, like there is a Prometheus, Grafana, Kiali. These are the monitoring tools and various things. So how to monitor these things using the service? So service mesh allows that, and you can capture your traffic. You can see like logs. So if you are running some application and you want to see like it is showing the 403 error or any type of error, so you go what you do. So thing is like you go to their logs. So inside the logs you check like what is the actual error and how you can solve that errors. So here it is like it will allow you for the observability. You can easily visualize it. So various open source tools are there. You can easily connect to this Istio service mesh. So another thing is resiliency. So as I told above, so it is like it will never give you some downtime or something, and it is like highly availability. So you can easily go through the means like whenever there is a downtime or something, you can route it directly. So that type of things you can do. So zero trust security. So as we connect every time to the service meshes and any applications or anything, so we need some certificates, right? So without certificates, it is like you can't, you don't have that security. Anyone will come into your home and get your things out. So similarly here it happens. So there are various certificates. So you know like SHA and all that type of the certificates. So that comes here, and you can also filter it, and you can add the various things here easily. So how Istio works today? So about that, as you can see like here, it is service A and service B, which we discussed at the start. So which was before. So now we are adding the Istio at the bottom. So it is like control plane, which can whatever you are doing to the service A and service B, so it can easily get their log files inside the control plane, and whatever you want to add to these services, you can do through the control plane only. So as you can see, there is a service A and this proxy. So Istio uses Envoy proxy. So what is a proxy? Sidecar, which we was talking about. So everything needed to the data plane It's means like service is like your in data plane, your service is like bada bhai, and envoy proxy is a chota bhai. So you like सब काम तुम छोटे भाई से करवाते. So similarly here it is. So envoy proxy does the same, and it is sidecar. So any policies you attach to the services and your application, it is organized by this envoy proxy. So it has benefits like you have the separate things and all, but it is like whenever you want to add some little routing to the application or something, you have to like complete installation of new new envoy proxy for that. So whenever you are running the service meshes on Istio, so Istio service mesh, so what happens, it creates the two pods, it not only create one, so it is like sidecar is applied. So there is various challenges we will discuss, but here it is like as I discussed, it keeps the track of service mesh, and control plane is like separate from the proxy. So that is the major like demerit of this thing, like it is complete separate. So if sometimes anyone wants to get into a system, it is little tough, but it is possible. So that's why we need to get this envoy proxy out of the picture. It is not like we can't, it is compulsory like we have to get it outside. We can put the security also, but thing is like it is nice to have the better support or better example or second type of things, so backup things. So similarly here it is, as you see, whenever I'm launching any Istio service application, any application on the Istio service mesh, so it is book info application which is like available in the Istio that Istio website. When you are installing the service mesh, they are giving the book info normal sample document already. So whenever like you are installing these things, it will download the samples directly, and you can easily get this pods, and you can see there is a 2/2/2. So what is a 2/2? It is creating the two pods for the same. One is a proxy and one is your normal application pods. So we need to get rid of this. So what is the challenges? As you see, challenges everywhere. So operational complexity. So what is this? So as you notice, there is a R here. So R is your resources. So whatever resources you are adding, it is to that envoy. So that is envoy, that purple, I don't know which color it is, but that is second one is the sidecar. So whatever is the resources, it is attached to it, and it creates whenever you are launching something, you have to create separate for all of them. So it is like you are increasing your complexity. So whenever you want application one out of this entire system, it is little tough. So that's why we have the afterwards there is the application mesh aware. I don't know why I put this application mesh aware, but simply it is like little complicated. Whenever you want to access to any job running inside the application, then it is little tough here. So inside the nodes. So after that, latency, as Sanchit discussed the latency, like how you will, it's like if you in the US and you want to access Mumbai once, so or vice versa. Yeah. So if application is like, it is like it contacts to the L4 and then L4 to the L7. I'm talking about that layers which I told. So after that, it is contacting the application 2. So it is like extra time it is taking, and that's why it is like here it is like 1 millisecond, but when you run large number of things, it is like quite of a hectic to wait for many times. So this will be beneficial in various things. So when you are training the MLOps model or like any machine learning things. So in machine learning also there is a service mesh we use, but many people don't know. So thing is we can connect that, we can use in the MLOps kind of a thing. Another thing is every company and everyone is more attracted towards this word cost. So as we see, like every sidecar is there and that's why it is like if you want to run for only one application, it is creating the separate things, and your budget is going, you are getting the bills of that 1 lakh and 2 lakh on your AWS or Google console. So similarly here. So yeah, Istio ambient mesh. It is new open source contribution product. So it is not available in production, but it is kind of a what we say product kind of a it is just a product project which is you can easily contribute. So open source, if you know, so it is not a production ready, so it is good chance for you also, like you can go and contribute, and in future it is solo and Google and there will be your name. So try to get that as soon as possible. So it reduces the cost reduction, simplify operations, improve performance. So how we will talk about that. So yeah, this image is from Istio, so I don't want to claim for that. So thing is, as you see, it is slicing the layers. So ambient mesh is slicing the two type of things. So in Istio, everything what we say, your Istio, but here it is providing you extra things, which is secure overlay layer. So what is that? If you want the security and everything, you will have that inside that one pod, and you don't have to create the different pod for it. Secondly, it is also providing you the routing. You can easily check the metrics. You can easily check the logging files. Everything you can check. So in future, if you want the L7 policies also, so everything is means like whatever you can do, it is easily available through L4. So why to use the L7, right? But in future, if you require, like there is sometimes you require, like you need the L7 proxy, so L7 policy, so use that by using this processing layer. So ambient allows the both of the things. You can do it easily. So it allows us to check the metrics, logging files, and authorization policies. So MTLS, which is used for the mutual TLS connection between the your one service to second service for the security purpose. So observability with Istio sidecars. So as we previously know, so in Istio, as we see, everything is in this Istio Envoy proxy. So there is complete different nodes, and as you see, like whenever you want to check the metrics or something, you are going to that Envoy and checking. But in ambient, what is happening? It will directly connect to the different types of a node, and you can easily view the means like observability. So you don't need the separate sidecar for it. Thing is, in future, as we are like data troubleshooting and all, so in future you can also add it to the means like in production version, there can be the possibility you can add the eBPF type kernel type of technology also. So how it is on you, like it is open source, so go and contribute. So this is the model. As you see, there is only one, and it is connected directly to the L7 if you want, but you don't have here the sidecars and all. It is completely removing your sidecars, and it is reducing your cost, and you will have the pretty beneficial wallet. So yeah, how if you want like many people are talking about these things, so to make it clear what is happening, so previously it was like sidecar proxy per pod architecture. So like you have the separate pods and proxies side by side. So as you know, below also see one container equals to one proxy, so it is creating separate one. But here in ambient, what is happening? One node is having only one proxy, so you don't have separate things, and you can reduce complexity, and you can reduce the cost and all. So I was going to use the GKE for this demo. So what is happening here? I'm using the GKE. Why? Because it is like it is easy to use, and you can scale up to 50,000 nodes, and you can easily get it. Means like there is free benefits at the start. Like I guess there is 300 credits. I guess 200 or 300 credits, and after that it is easily available, and it is by Google, so you can get the customer support and all. So that's why I use the GKE for this. Another thing is, as you can see, previously as I that showed one example for you. So there was a two ports, and here you can see it is creating this Z tunnel. So in this Z tunnel, what is Z tunnel here? So Z tunnel is something proxy which is used to transfer that your anything like messages, routing and anything. So as I told here, yeah, so it is L4. So here we are using this Z tunnel proxy to communicate with anything. So you can visualize it. I am using the KNS, so to make it more clear. And after that, yeah, we have the CNI also. So what is CNI? It is like connectivity thing. So to learn about the CNI, I would recommend like means like I see like major students are here, so I would recommend like learn about these technologies, CNI and this stuff, Z tunnel, and contribute to the open source. It will be beneficial for your futures. So another thing is as how I installed. So there is a you can easily install on the Google Cloud Shell, and then there is when you do this command, which is istoctl portal install set profile ambient. Only you have to set the profile ambient, and then thing is previously in Istio you have to like completely restore your services. But what is happening in the ambient, it is like it will not stop your cluster or anything. It will directly attach your any application if you want. So it is like best thing, like you don't have to restart it. You just connect it and you will see like there is pods are creating. So here it is creating, so you don't have to like apply differently all. So it provides defaultly everything and all. And after you click on any of the Z tunnel, you will see like it is connected easily, and how the package distribution is going on. So you if you have more doubts, you can let me know in the break or something, so I will talk about the same. So there are various blocks available for the same, and there is one training and certification thing also. There is complete demo. So how the Quick Labs is there. So similar to Quick Labs, it is where you can there is a complete environment is given. Inside that environment, you can easily do this stuff, and let me know if you have any doubts. There are various podcasts and blogs also. So thank you.
Thank you so much, Rohit, for an informative session. Okay, guys, before we like go ahead and have the lunch, because it's already 1:32, so we would like to know if you are like putting up the stories and the posts on LinkedIn with our hashtags and all our filters. Okay, great. So guys, you can start off with the lunch now. Because it's already the lunch time, and help yourselves with the lunch. We would like to have you all and full with the stomach, and then we can have the session again after the lunch. So we have the whole session planned.
Hello. So we have lunch on 4th floor. There is a separate hall for you to have lunch. Additionally, we have set up some props at the terrace. You can go there. I am aware that there is a network issue in this basement conference room. So use and utilize this time for networking. Additionally, you can share your pictures on social media. And I will then ask in a group, row-wise, to go for lunch. And rest of you can go to the selfie point or can network amongst here only. Is it fine? Yes. And please do check your emails also. We have shared all the hashtags and the channels to be tagged. Additionally, our team have created Instagram filter also. Just click on the link. It will take you to that filter. Do share post there as well. Take selfies with our speakers and do share it on your professional social media, LinkedIn, and on Instagram also, and on Twitter. Is it clear? Yes. Speakers for the lunch, and later I would be sharing the attendees in our batches.
So our next speaker is Ashok Vishwakarma. He is a Google developer expert. He has 14 plus years of experience and has great knowledge of cloud and cloud tools. So let's welcome Ashok from Noida, Uttar Pradesh.
Everyone, लंच के बाद का सेशन हमेशा अच्छा नहीं होता, ठीक है? I got that warning. But are we still excited? Yeah. Cool. So I think इस slide की ज़रूरत है नहीं. So let's move on to this. So web have evolved a lot. Okay, like we have seen in the early days just a plain text, and now it's become much more complicated and much more complex. So when the first in 1960s, when there was a supercomputer and all those things started happening, people started to divide and distribute the workload on that particular specific system, and that's where they actually coined a term called time sharing. So time sharing is a situation that because they didn't get a chance to have access to that particular PC on a very longer time, they divide into a time sharing basis, that some specific time duration I'll be doing that, something on, and these I'm talking about various big organizations like and to institutions like Stanford University and all those. They never had that a big computer, so they need to have some sort of mechanism to share the data. So sharing become very essential when we talk about our day-to-day computing. So this is about that only, and let me quickly cover a little bit on the agenda side. So we'll go and talk about what tenancy is, how tenancy has evolved so far, and we also talk about the benefits and drawbacks specifically we have on the tenancy side, and how and what are the mechanisms some companies and some specific tools which we have in the market doing to kind of work around on those specific limitations. And then I have built some one smaller utility which can reduce all those specific effort which you need to do in order to get started with it. And then we'll take up some questions. Okay. Is it not working? Okay, so typically we have two types of tenancy model as of now. The one we call it single tenancy. What happens in single tenancy that you set up one environment with every resource specific to that, and that one environment is going to cater one specific client only. So suppose if you have 100 specific clients for the product, you will be having to have every specific resources assigned to that one specific client, and then you have to distribute that one specific instance for 100 specific clients. So you'll need at the end 100 those kind of similar and common resources for each and every specific client. So this is a kind of setup it actually gonna look like you have your application, you have your database, you have your all other specific dependencies, and it's going to get deployed to every specific tenant. So tenant here is the customer actually. So suppose if you want to sign up for Google needs to set up everything for you specifically, that kind of architecture which we talk about. And this is still in practice. Lots of companies do that on certain various regions and certain specific benefits around that. And the second one, is multi-tenancy, where we think that we have developed a lot, and we nowadays do our specific software and specific day-to-day development in this particular model, where we try to make use of sharing systems, sharing resources as much as feasible and as much as possible. Like we don't go and create multiple databases based on every specific client. We don't go and create multiple app instances based on every specific client. So we kind of moved and developed ourselves towards having a single tenant-based system to a multi-tenant-based system. And nowadays, this is what is widely used. But there are certain labels of multi-tenancy. So the first one, which is very simple, that's called table-based tenancy. So it means that every specific row of your specific data will attach to one specific tenant, and you identify with that. Like the way we develop the application, the simplest multi-tenancy. The second one is where we add little bit more complexity and go on a divide. We may have one single database instance, but we may have multiple databases, or we may have multiple schema on that particular databases for every specific line. And the third one is the database one. So I'll go and iterate through everyone each other. So this one is row based, like we used to develop application as of now. Like you create one database for your application, and then every specific, and you may have a user table, you store the user information over there. If user uploads photos, you just attach that user ID to those photos which user is uploading, just to identify that which user owns what. So that's the very simplest level of multi-tenancy, and that's where the majority of things which we do on a day-to-day basis happens. But it has certain limitations which we'll talk later down the line. The other one was just talking about the schema based, or maybe the multi-database based. So how many of you have worked on PostgreSQL? So PostgreSQL and other specific databases have the one specific called schema. So by default it's public schema, and you can create other schemas where you can define your database. The difference between having multiple databases and multiple schemas is that you have one database, and within that you create multiple physical separation of your data. Like, so one specific client can use schema public, one specific client can use their own schema, and everybody have their own database, their own specific data stored in those specific schemas. So you don't have to go and talk to a specific cross databases and all. Okay, technical glitches. That's fine. Okay. And the third one is database. So this talk is purely based on this particular model, where we have certain requirements and certain situation where we need to have every specific tenant assigned to a separate database, and there are certain drawbacks to it, and there are certain benefits to it because that. So we'll be going and discussing about that. So a typical architecture in this scenario looks like this: that you have these multiple tenants. You have single instance of your application, like this could be a web, this could be a mobile, this could be any specific application instance which you want. And then you have multiple databases which this application talk to. So based on customer 1, it's talk to the database 1. Based on customer 2, it may talk to the database 2. So every specific customer, they have their own data physically separated and physically available for that particular customer only. But your whole other specific resources, like your application container, your services, your actual application, all these are into a single instance. So, any questions so far about NNC or anything? I can take up and then I'll move to the benefits. I just wanted to be a little bit interactive because I see that people are a little bit, after having lunch and all those, people are a little bit in that mode. Okay, so let's move on a little bit on the benefit side. That actually what I'm trying to do here is I'm trying to introduce much more complexity, because dealing with one database is always easier, no? Now I'm saying that you should deal with multiple databases. So why I'm actually saying that, let's talk a little bit about that. So first thing is it gives you enhanced security. So I mean, security is very essential where the data is coming through, and now you are physically separated every specific database for every specific client. There is no any accidental things which can happen that one client can have access to another specific client data. And that's a physical separation you'll achieve with this particular architecture, which have an inbuilt enhanced security on a physical layer. The second one is it's also cost effective. So think about a situation that maybe you're building an application where you're having certain small clients and certain big clients. Scaling databases are always being tougher. Like there are certain databases which does not support horizontal scaling at all. You need to go and actually vertically scale them. In those specific situations, what's going to happen is that your smaller client will also be suffering because of your bigger clients, because they need to have that kind of scale. They're having that much of a data, and because of them, if you're not able to scale that particular level, every client of yours in the system will be suffering. So this also helps you in that particular regard. And also there could be a situation where one specific client which is very big, you can just separate it out completely from the system and give them a separate database instance, where every other client can residently sit on one single instance or one single specific stuff. So this also gives you that, because of that separation, it become much more cost effective rather than going in physically or I would say vertically scale that database to a level where it's reached a lot in terms of cost. The third one is it's very easy to upgrade. Like I mentioned, that you can pull out any database and you can separate it out, but your application and all resources are shared. So when you need to push a new update in your app, it's going to be one place and available to everybody. There are certain guidelines, certain rules, and certain delivery-based specification you can set up. Like you want a specific geographical location based delivery, or you want a client-based delivery. Those specific configuration can be done on the application level, but the idea here is that you have to ship that feature once to make it enabled to everybody. Whereas in single tenancy, you see that every application you need to deploy and distribute on every specific instance where the application is running. And because we have the database separated, now it's become very easy to back up and restore. You don't have to go and and actually filter out the data based on the clients, based on certain other specific parameters, and then back up and actually back up the data. In this situation, you go the database A with the client A, and you back up the database separately, store in your specific storage, and then restore the way you want. So it makes DevOps life very easy, because backup and restores become very much more efficient and much more easy too. And because in single tenancy, what happens is that you have to create all those resources for every specific client independently. In this scenario, adding a new clients become very easy. You may have certain application logic written which can create the database on the fly within one specific machine. And then all your things become is like adding one specific client just as simple as signing up on a very smaller form. And because of that, you can add as much more client as feasible. And in the single tenancy situations, you need to take all those specific hardwares, all those specific resources, set up them separately, and then you'll be able to onboard a client. And it also helps in scaling your database, as I mentioned earlier, that vertical scaling versus horizontal scaling. So here you can scale horizontally towards one specific client basically. So you also have heard of concept of sharding in databases. Sharding happens based on some specific unit, like it could be time, it could be time-based sharding, it could be geographic-based sharding, it could be client-based sharding. So you can have that, have those independent thing available inside the client database itself, but the first level of sharding you have already done, which is the client-based sharding, and that reduces a lot of database loads. So these are the benefits, but as I mentioned earlier, that this is a complex system we are introducing. So there could be certain drawbacks as well. So let's talk a little about that. So first thing is the database connection. So in your very simple table-based multi-tenant or maybe single tenancy, what you did is that you created one connection. You created one specific connection, and that connection is serving every specific client you have. You don't have to worry about maintaining multiple connections. But in multi-tenancy, where you have multiple databases, every client needs a connection for their specific database, and that too on runtime, because when the request comes in, then only you will be identified on your application layer that which particular client is making the request. And it's also have a little bit of a different implementation.
separate tenant, and for each tenant and databases. And in all the databases we are having some and notices. So this is the place where we needed a multi-tenancy, and that's why also we are using database as a not MongoDB, we are using ArrangDB database, which supports multi-tenancy at its best. Okay.
Okay, I think it's resolved. So the connection which I was talking about, because the authentication, yeah. So authentication, I was talking about that. It's good to have a separate authentication, but in multi-tenancy it becomes necessary. Otherwise, you're not able to do. And okay, so the other challenge which is come is about the migration. So migration is, so your database, because I'm talking about a specific system where you have very strict schema. I'm talking about SQL databases, not NoSQL databases where you have loose schema. And in those specific scenario, what you have to have a challenge, like suppose your one table schema changed at one specific place, and now you have multiple multiple databases where that schema is being used. Now you have that particular complexity where you have to go and make that schema change in every specific database. So that's another complexity which comes with multi-tenancy itself. But there are certain workarounds, so you don't have to worry about them, and let's walk them through one by one. So the database connection thingy which I talked, that every request you need a connection. So what we generally do in multi-tenant architecture is we kind of create a connection cache which is in-memory cache. A request comes in and we take that tenant identifier from the request, go to the cache, see if the cache has the connection with it. If it's, we return the connection and our job is done. But if connection does not exist, we make the connection and then store that connection in the cache and then return the connection back. So it's a very simple implementation, and some specific scenario we call it the TIS, the tenant identity service, which kind of gives us the tenant identity and everything else. And because we are introducing a new system which is called TIS, it also raises a couple of times that it could become a single point of failure. If our TIS is down, okay, then my request is coming, but they're not able to identify which tenants they need to go. And in that situation, the user will not able to access the application at all. So what we supposed to do in those scenarios, and to scale that further up, what we can do is we can just have multiple instances of TIS running in the background. And if one is down, then other one can take its place. And it's very simple utilities, just it doesn't take that much time, it doesn't have that much of a resources to bear, and it does not cater to that much of a heavy cost upfront at all. And the authentication problem which I mentioned, that there's a problem. So there's a mechanism called auth token as of now, which I shared in the example of Google. You can see the similar example happening everywhere. Like if you log into AWS, you see the similar experience. If you log into Atlassian, you go to id.atlassian.com first, then it gives you a token and redirect you back. Even Slack does the same. Everybody is nowadays separating their authentication process from the application process completely different. So that's a similar way we can tackle that particular challenge over here. The other problem which I talked about, that was like the schema migration thingy. So there are cloud services like Google and Azure, IBM and AWS. They pretty much have certain services which lets you distribute your schema in one go. Some specific some specific service provider call them schema posts, somebody call them something else. So this, what it does, it lets you create a schema. That schema sits one place, and as soon as you instantiate a new database, it takes the schema from there, and then the periodic sync should be happening. So every time you make a change to the schema, they publish that particular change to everywhere else. There are certain downtime comes in handy, but majority of the time these things can be automated at all. So you don't have to worry about making the changes in the schema or worrying about 100 and 1000 of databases you are running for every specific client. So we have talked a lot about this. Let's see how this whole thing comes into the play. So this is a very simple multi-tenant architecture which I create when I create certain projects around that. It contains your application users, so they are denoted as tenant A, tenant B, and tenant C. These are the workspaces you say or something, and some companies you create, or maybe user you can tie to. And then we have a separate authentication server like id.atlassian.com or maybe accounts.google.com or certain separate authentication servers. And then we have a landlord database, which is a kind of a part of TIS, and it also manages all the clients and customers you have. You store their database configuration in that, you store the common data in that particular database. And that particular service have another service which is tenant identity service, which talks to and identify that which tenant you are needing the connection to, and that gives you the connection to the connection cache from the database. And this is the one flow where authentication comes to the picture, and the other flow where it doesn't come to the picture. So let's go a little bit deeper into this. First, you see that you have a tenant which go to your auth server. Like suppose you come to the google.com or maybe gmail.com, okay? You click on that sign in button. After clicking on sign in button, you will not stay on Google or gmail.com. You'll go to accounts.google.com. That's the authentication server I'm talking about. And that will need to talk to or attach to a landlord databases which have information of your email address, password, all other specific information, and that you can configure the way you want. And then once you have that particular information with you, that which particular tenant we are talking about, you go and talk to the tenant identifier service and ask them that, can I have a connection for this particular tenant? And it can talk to the database cache which have the connection established, and he can return back to the connection, and that you can authenticate the user based on your other specific logic. And similarly, how the application flow would be a little bit different. So you start from there, you have the tenants coming to the request, but now your tenant have a token, okay? So you don't need to go to the authentication server to get that token and all that specific stuff. You simply go to your application, give that application that token, and then application talk to your tenant service with that token, asking them that, can I have the database connection? And it's take the database connection from the cache and all the data which they require and return it back. So all of these, there would be certain, if that's the very good, the companies will be using it. So here is the list. So here's the list of the companies who use multi-tenancy in their system, in some part of their system. And majority of these companies you definitely will be familiar with, but there are other companies who are purely in SaaS, and they have to use multi-tenancy on certain guidelines the SaaS industry have in their own. And like the Salesforce we're talking about, Freshdesk we talk about, and MailChimp, all these companies are kind of SaaS-based companies, and they have to use that particular multi-tenant architecture in their application. So when I was working on this specific stuff, I primarily code in Node.js for my API requirements, and specifically using Nest.js as a framework. And when I was building one specific system, I figured it out that it's very complicated to write that TIS layer in the application system itself. Like every request, you need to find the identifier. Based on that identifier, you need to go to database and kind of figure it out, either we have the connection or not. So I kind of wrap all those things up and created one specific NPM package, which lets you do the couple of things. You do that next time, okay? So the first thing it does, it actually do is it lets you have the tenant identification. Like you give it a token, and based on that token, it gives you that what specific tenant are we talking about based on the token. Next, please. And the next one is the connection. It also have built-in cache. The cache is based on in-memory Node.js in-memory as of now, but you can pass in your own memory structure and your memory model so that you can use that. But it also gives you the connection storage, the in-memory connection storage, which you can avail. As of now, because I have extensively, as I mentioned, that I have worked only on SQLize for this particular thing. I have built this very centric to the SQLize ORM, which is, I think, is the best ORM for any SQL databases out there, specifically on Node.js. So it's available for SQLize repository only. And it works. So if you have a very small requirement, let's suppose one specific use case, you want your data to be stored in dynamic table. Like suppose you are generating reports, okay, and you want that report to be pre-computed, pre-generated, which never going to be changed. Like if you generate a report for December 2022, whether you are accessing it on December or you are accessing it 10 years down the line, that report will remain same. So in those specific scenarios, what we tend to do, like we create multiple tables on the fly, and we store the data in those specific tables. So in those scenarios, this is very helpful. So how that whole thing works is, you just, I mean, how many of you have used Next.js? Okay, one or two. So this code will be a little bit unfamiliar because but if you have if you have worked in Angular, this is going to be very much similar because Angular and Nest have very similar architecture, very similar the way the DI and everything works. So this will be a little bit on that. So I have created a module which is called tenancy module. That tenancy module you need to initialize. So there are certain functions, initialize for root, initialize for feature, initialize for root async. Root asyncs and root have one specific difference, that it also gives you a method which gets internally called, and you can have asynchronous methodology over there. And it's have a certain dependency to it, like it have a request and landlord as service as a dependency, which can take the information from the header that what your specific workspace is, give that workspace as a client, and then you can just use that client information to connect it to the database and returns that database as a provider. So every specific request afterwards, if that is already available, that tenancy model will give you from the cache directly. Otherwise, it's come to this particular code and give you that information. And because we have, as I mentioned, that we need to define repositories based on either we're talking about the Lambda database or the tenant database. So Lambda database will have a separate SQLize connection, will have a separate models and separate tables around that. But on a tenants databases, we can assign those specific models, SQLize models to the tenant service using this inject tenancy model. So this asks for your model and you inject that, and it works like a very similar repository you access in SQLize. So it's available here. You can go and try it out. So as of now, it's not that popular, but yeah, maybe. Any questions anyone have? Yeah.
Can we use auth token in subdirectory?
Sorry?
Can we use auth token in subdirectory?
Can we use auth token
in subdirectory?
I didn't get that. Subdirectory, what do you mean about subdirectory? You mean about the subdirectory from the URL perspective?
Yes, URL perspective.
Yeah, you can have that. So see, but there would be a challenge over there. If you are using that on a subdirectory, you have to set up somewhere on your application server which is taking care of the routing to identify that you are talking about this particular directory and need to go on that particular application. And why you want to do that? Any specific reason?
Because it's easy to.
I mean, it's easy to map the particular folder in your subdomain as well. No? Okay, let me tell you why it's become easy. If you do not use subdomain but use subdirectory, you will not have to worry about cross-domain policies anymore.
Like.
Okay, so xyz.abc.com will not be able to share the local storage resources or local session storage resources on the browser side to xyz.abc.com, some different subdomain. So that's why it would be beneficial if you're doing to do on subdirectory. But yeah, that would invoke another challenges based on application routing and all, but yeah, you can do that. Any other question?
No.
Yeah, can you pass the mic over there?
So I want to ask, like, how do you tackle database architecture? So the
will be a lot of databases, right?
I'm not able to hear you.
Hello.
Yeah,
You're audible. So I'm asking, like, how do you tackle servers upgrade, database upgrade? Like, so you want to
Okay,
upgrade
upgrade means like the database version upgrades.
Yes. So there will be a lot of databases, right?
Yeah.
Now you want to upgrade a lot of servers, like.
Yeah, so as I mentioned in the schema push thing, that similar services is also available on the cloud to manage your database instances. But I also see that majority of time that particular problem does not come into that handy. Like we do not upgrade databases that frequently, and it would be one-time activity which we can do in a very optimized and organized way. Like similarly, like suppose if Google needs to do some migration activity, they can just announce everybody that from this time duration our services will be down, and we can do that migration. But yeah, I mean you can automate that as well, but I would not suggest to do automation on the database upgrade because it could have breaking changes, and you end up killing down the whole system at once. So you could go in the similar and very old-fashioned way, like having little bit downtime and announcing everybody up front, and then getting that particular time duration as a time where you can upgrade these specific activities.
That helps.
Anybody else? Yeah, here.
Cons of serving data from database.
Cons of serving data
from database.
So, I mean, cons of serving data from one database.
One database.
Okay. Rather than using this architecture, you want the very simple version where you have table-based, multi-tenancy. So, as I mentioned on that particular time as well, like there would be situation where you have tons of clients, okay, and the client will vary based on the size. So that's the one specific things where certain databases does not allow you to horizontally scale their system. You will end up having that particular challenges where every of your client will be suffering because of those big clients, which you don't want. Like in a very rude example, if I say that nowadays we all compile our JavaScript into ES5 specs, isn't it? Because there are certain browsers who are not on ES modules yet. So by doing that, we are penalizing for those people who are upgraded their specific browsers as well, isn't it? Like they also need to get that ES5 bundle where they can have much more optimized and efficient bundle of ES modules. So that kind of similar stuff you'll be doing if you are having big and small clients. Everybody will be in the same bucket.
Thank you.
And the other reason would be like there are certain requirements in SaaS specifically as I was talking about that they don't want you to have their data. Okay? And in those scenarios you don't have any other way to do it. You need to build a system where they can host their database on their premises and you will allow via some private key or some mechanism to connect to that database and serve your application. In those scenarios, you don't have even have an option to keep a single database for everybody. Anybody? Anything else? Okay. Thanks a lot. Have a good day.
Thank you so much, Ashok Vishwakarma, for the informative session on the particular topic we have not even thought is such interesting. So our next session is Zero to Hero in Machine Learning using Vertex AI. So our next speaker will let us know how Vertex AI enables you to automatically build and deploy state-of-art machine learning models on structured data at massively increased speed and scale.
Can we clap for the next speaker, which is Vaibhav Malpani? He essentially knows about Python, GCP, AWS, NLP, Docker, BigQuery, Dataflow, SageMaker. So I welcome you, sir.
Yeah. Sure.
In a company called Incido Inc., which is in Pune. Uh, this is my LinkedIn profile. You can scan, connect, ask any questions that you have. I'm sure after this session you're going to have many questions. So let's start. So I'll start with the very basics, but I'll go through this very fast. I know everyone knows machine learning, but what I'm going to teach today or going to show today will be a bit different way of looking at machine learning. So what is machine learning? It's application of artificial intelligence that you create using data, and it basically analyzes the data and makes decision that a human would do. Don't you agree?
Yes.
Okay. So there are majorly three types of machine learning. Everyone knows about it: supervised, unsupervised, reinforcement. Supervised is where you give the labeled data and on basis of those labeled data, it is able to predict, okay, if this is a dog or a cat, all these kinds of examples. We'll go to example later on. Then there is unsupervised learning, where you do clustering, and then reinforcement learning is where the model learns from its mistakes that it do, or the rewards that it gets. Just like the way a child learns to walk, right? He falls, he understands, okay, if I'll fall, it will hurt me, and then eventually he starts walking. So we'll focus today mainly in supervised learning, and there are two types in supervised learning, which is classification and regression. Classification is basically when you are trying to classify between two things, let's say two objects, which is if this is a red ball or a blue ball, is this a dog, cat, or a goat, something like that. And then regression is where you are trying to find a specific number. Let's say what will be the price of my house in 10 years. On basis of the past data, you'll be able to do all of those. So this is where regression comes in. Now, there are a lot of problems that we have with the traditional way of building machine learning. The biggest one is you need to have good configuration hardware, and this is a big issue. Currently, when we are trying to build a model, we don't have a GPU to train on that. It's easy if you are creating something very small with NLTK or spacey, but if you are going into transformer, Hugging Face and all that, you will require GPUs. There was one of my projects where using CPU, it was taking me 3 hours to build the model, and using GPU, it took me 12 minutes. So it's that big of a difference. So you need a good configuration hardware, and good configuration hardware comes with a good cost as well. Let's say you get that hardware, but you need to now deploy the hardware, deploy the model, right? Let's say you have created the best model in the world, and tomorrow 1 million people are trying to access that model, or run the API that you have just created. What are you going to do? You are not ready for that 1 million, right? So you need a way that it should be scalable as well, and it should be highly scalable. Then let's say you get that as well, but you need a lot of machine learning expertise to actually understand, okay, is your model working correctly? How do you actually make it better? All those things. And also you need to be efficient as well. Let's say you build a model, but the API time is, let's say, 7 seconds to just understand if it's a dog or a cat. Would you think your app will work? So you need something very efficient as well. So these are all the issues. So how do we solve all of this, right? Vertex AI. It solves all those issues. Also, everyone knows KB. Okay. So what is Vertex AI, right? You train your models with very minimal code or no code to be, like in some cases, there is no code that you'll have to write. It's a unified way of running all the ML workflows. There is a lot of things. We cannot go through each of them today, but I'll go through most of the important things, maybe not important, but most of the things that I could cover today. And you have to manage your model and confidence that I can show you in the demo. And it has pre-trained APIs for vision, natural language, and video as well. So when I say pre-trained, you don't have to, let's say you just say, give a photo of this, I click a photo and I put it to the pre-trained API of the vision. I'll be able to see things like, okay, this is a auditorium, there are people, it will also detect the faces, where the location is of that face, all these things you'll get just by an API call. It's very powerful. I'll suggest you to try that out. Today, I'll also show you what are the different types of Vertex AI problems that you would solve. So there are majorly 4 things. The first one is image. So image classification, object detection, that is the example I gave just now. Tabular data is something we'll go into deep, which is regression and classification, and then forecasting. So I'll show you in the demo as well for the tabular one. The next one is text, where you can do text classification. Let's say on a basis of text, you should be able to understand, okay, this text belongs to an entertainment category, or this belongs to a politics category, something like that. Then entity extraction is, let's say, I say a sentence called, we are having Google Cloud Community Days at Bhopal. So entity extraction will actually understand, okay, from this sentence, we is not an important word. Cloud community is an important word. Then we have Bhopal. So all of this entity extraction is basically getting out all the information from a simple text line. And then sentimental analysis is just to understand if, are you angry, sad, from the basis of text. Mind you, sarcasm doesn't work here. Then there we have video classification and action recognition. So in action recognition, very interesting, wherein let's say you are giving a video of someone playing baseball, and you will be able to understand are they playing baseball, basketball, something like that. You can train your models according to it, and then eventually it will be able to figure that out. So how does Vertex AI tables help? Like I told, we'll specifically go into Vertex AI tables. It helps you build and deploy, okay? Machine learning models with literally no code and no machine learning expertise. So I'll show you how to do it today. Of course, I've pre-built the model because it takes around 2 hours to build, but I'll show you the steps that you could do. So if you just forget, you can refer to it and you'll be able to do it. So what are the example problem statements that AutoML tables can solve? These are the one I told about predicting housing prices. One is predicting the possibility of getting diabetes. So there is a very famous data set on Kaggle about predicting diabetes on basis of various things. It has all the blood information, all that. And then you'll be able to predict, okay, this person has this thing, so what is the possibility that this person can get diabetes? And if you see, I've highlighted the last one. That's the demo that we'll be seeing today, which is mobile price prediction on basis of the features. So let's say, what is your RAM, what's your battery power. As a human, right, I'll just tell you my mobile specs and you'll be able to say, okay, this is a high class phone or a cheap phone, right? So, but how will model do this, right? And I'll show you how does it even understand, okay, which all things are actually, contributing to the price of the mobile. Example, let's say I just tell you I have Bluetooth in my phone. Everybody has Bluetooth, right? It does not help you that I tell you my phone has Bluetooth. But if I tell you I have a 7-inch screen, something like that, you'll be able to say, okay, it's a high premium product, but not surely. I'll show you that in the demo as well. And this is one of the most remarkable use case. You can go to this link, tiny.cc fox_news. There's an underscore there. And I'll tell you about this. By the way, Vertex AI tables was called AutoML tables earlier, and this is a use case that they had done in 2019, which was very interesting. What they had done is, they were able to predict when the wicket is going to go in an Australian match. Fox News has done this, and what happened is, once they were predicting it, their viewership went up by 150%. That's a huge thing, right? In an Australian match, not an India, New Zealand. Yeah. So yeah, I'll suggest you to read through this. And this is the problem statement that I just told you before, right? By predicting the mobile prices on the basis of the features that we give. So this is a data set on Kaggle. You can download it, try for yourself. Caution, Vertex AI is not very cheap. I'll suggest you to create a new account and then do it. You get $300 free. So it's demo time. Yeah, so this is it visible at the back as well? Right? Do you want me to zoom a bit? Okay. So I have 3 data sets as of now created. I'll show one by one. This is the first one that I spoke about, which is building a model for detecting the mobile price range. So how this works is, it goes from 0, 1, 2, 3, 0 being the cheapest and the 3 being the highest. So this is a classification problem that we are trying to solve. So how do you go about this? You come to Vertex AI, you'll go here, search for Vertex AI, you'll get this Vertex AI. You will be redirected to the dashboard. Since the first time you have created, there will be nothing there. You just need to enable the Vertex AI API. Then you go to dataset. So once you are here, you do create, you give some name, and then you decide, okay, what is the type of your data? Is it image, tabular, text, video? So you can choose any of those. And even in that, let's say you choose image, so maybe you have different types, right? So for this we'll go for tabular. And then you have regression, classification, or forecasting. So you just click on this and do create. I will not do that because I've already done this. So once you create, you will be redirected to this page, which is a source. So now this is being shown this way, but let's say when you log in, you will be asked, okay, put the Google Cloud Storage. How many of you know Google Cloud Storage? Okay, so you need to put wherever you have kept your train.csv, and you need to give the path. Okay, this is my train data. Once you have done that, you go to analyze. In analyze, you will be able to see, okay, what are the different types of data, what is my column names and everything. Of course, you can see it in Excel as well, but here also you're able to see. Okay, so if you scroll down, you'll be able to see, okay, this has all these kinds of columns, and we can say features, which is battery power, Bluetooth, clock speed, dual SIM, all these. So there are 20 different types of features. You can go to that link and you can browse through that data if you want, but this is something I'll zoom through. Once you have this, all you have to do is click on this blue button, train new model, and that is it. Don't you guys believe, right? You guys don't believe? So all you have to do is click on this. Now you say what is the problem that you're solving. So ours is a classification problem. You choose classification, you choose AutoML. Custom training is, let's say you want to put your own model. That is something an expert can do. But let's say we don't want that thing. We only want the auto thing, right? So you choose AutoML. You choose what is the data set. You want to create a new model, a new version. This is very helpful while building the versioning. You say what is the target column. So this is the important part. So there is a column called price range. This is the column that we are trying to predict. So price range basically has 4 values, 0, 1, 2, 3. You can again refer to the data set. And that has labels. Key, if this has this much RAM, battery power, all this thing, it belongs to price 0. It belongs to price 3. Something like that. So you need to predict that, right? You're building models to predict price range. So you choose price range over here. You do continue. You can look through things. If you want to create a new thing, you want to create a property, you can do all this. There are statistics as well. So if you click on this, it will take a bit of time though. I'll just show it after this. And then you click on continue. Once you have clicked on continue, you say for how many hours do you want to train the model. No, you are not sure, right? How many of you have built models on their local machine? Only 1, 2, that's it. So you would have seen, right? Once the model training is done, it stops by itself. But here you will not know, right? When to stop, how many hours are good enough. Let's say you train for, let's say 15 minutes and the model is not working fine. So what you can do is put a big number here, put like 3 hours, 4 hours, depending on the data set. I had 2000 data points, so I just put 2 hours or something like that, and it was able to train it. There is one more interesting thing, which is enable early stopping. And if you can see this trend in Google Cloud everywhere. Google Cloud tries to save your money wherever possible. I'll show you on the home page also. There is a tab called recommendation. Let's say you have a CPU or a VM running for 2 hours or let's say 2 days and you are not actually using it. It will actually recommend you, please stop this. Or let's say you are not using the complete capacity. You have taken 16 core and everything, but you are hardly using 2 cores. It's able to understand all those things and it will say, please downgrade this. So this is the same concept there. They're trying to save our money. Let's say you put 3 hours and your model has been built in 1 hour. So it will just stop after 1 hour and it will save you cost for 2 hours. Once you have done all of this, your start training button is activated. Once you have clicked, you have essentially been created the model. Too tough to digest? No answers. Is everyone sleeping? No. This you can answer. Okay. So okay, let's go ahead 2 hours. Now you have built the model. The training is done. You will be coming to this page. You will see 2 interesting things here. One is the confusion matrix, which basically tells you how many of the times was your model right while predicting each of those labels. So if you see out of 0, when it was 0, it was able to predict 100% of the time. But in case of 1 or 2, it was only 92% of the time. Still, given the ML standards, anything above 90 is very good. Then this is the most interesting thing, which is the feature importance. This tells you, you can read through this by the way, but I'll just say this tells you which of the feature was actually more important for the model to understand. Okay, from this feature I am able to, this feature is important to me. So don't you think if the RAM is higher, the probability of it being a pricier phone is more? Don't you think if the battery power is more, it will be both of the things basically, RAM and battery power is more, it will be costlier. So px height, px width is how much is the height and the width of the phone. Even if that is higher, it will be, the cost will be more. So it's telling you, okay, these 4 or 5 things are actually very important to me, and all of these data which is below this, like Bluetooth, 3G, every phone has 3G, right? So it is of zero importance. So here you are able to understand, okay, what are the important features. Earlier, let's say you are building your own model, you will have to do this by your own. You'll have to understand, okay, and this is an easy thing, right? Let's say you're building a very complex model and you do not have the domain knowledge of that. Think of this. Would you be able to understand, okay, this feature is important and this is not? Do you think? Yes. But this does, right? So this is a very, very big feature, and it's very underrated as well. So, okay, now you have evaluated, you have understood, okay, how the model is, how is it working, what is important, what is the confusion matrix, what is the probability that, it will be correct or not, all those things. So you just come here, click on deploy to endpoint. This single button is so powerful that even if you put 1 million requests on it, it will be easily able to handle it. It runs on containers in the backend. It will just scale up the containers. You don't have to worry about a thing. Of course, it will cost you, but that's a different thing. But you can serve to 1 million records. Even if it's in a second or a minute, it doesn't matter. Don't you think that's interesting? Okay, so once you have this, it tells you what is the sample request API that you'll have to create. So this is how the body would look like. This is what is the endpoint, what is the curl command. Everyone, curl command? Okay, so I just have taken that curl command and put it in my Postman. And I've given, okay, this is my battery power, Bluetooth, all those features. And I'll just try to send my request. I think I'll have to run my token again. The token is expired, which is supposed to happen on a live demo. How many of you use Cloud Shell? Use it, guys. It is very powerful. I'm just amazed how many things you could do. You have your own personal machine on cloud. So that's a very interesting thing. Yeah, so I have this. I create a token here. So I created the token earlier. It got expired. So by this you actually understand how secure it is, right? No one can just, even if you copy this token, you won't be able to hit the API. I'm not sure what is happening. So, okay, I don't know. Sorry?
Internet is down again.
Is it?
Working locally in Scratchpad.
No, so that is a different thing, right? Oh, Scratchpad is a different. Okay, anyway, I don't know. There's some internet issue. It took some time, but we have the response. So I'll just walk you through the response. So here you see classes 0, 1, 2, 3, and below that you have scores, which basically says what is the score of 0, what is the score of 1, 2, and 3. So how many of you know what is this E minus 0.5? Can someone say what is this E minus 0.5? Sorry? Yeah, so 10 to the power minus 5. So it's such a small number. So of course that is not our class. If the second one, if you see, it is 0.99999. So it is that much sure, that 99.9% sure that it belongs to category number 1. And then for 2 and 3 also it has a very small number. So it's just that easy. I'll just try once more. It should not take 27 seconds. Yeah, see, it's less than a second, right? The response comes in less than a second. Okay, so do you think this was interesting? Yes. Are you interested in some other demos as well? Yes. Do I have time to do it? No? Okay, I'll still do it. We are already late, right? So, sure. I don't think that will take me 2 minutes. Can someone be in the crowd? I'll require a mic there. So I'll not go through very much details about this. So this is a data set that I've created on text data. So it is around 99,056 some records, and it is all label data. And if you see, the labels are art, culture, business, comedy, crime, education. So these are all the labels that this text belong to. Mind you, all this is in English language. So what I'm going to do is, we'll try out this model today. The net is really slow. Okay, till that time maybe I can show you this one. This is one more data set, dogs and cats. I know everyone loves it. So you will be able, if you see, I've just put 11 cat images and 10 dog images. That's it. That's my data set to train a table on cat or a dog. You can put anything, by the way. It could be goat as well. Cat, panda, kangaroo, anything. You can just put 10 images. That's the base thing that you have to put. Click on that blue button and it will be able to do that. So let's try this one as well. Yeah, so this has been created. I'll just go to deploy and test. Everything is same. It also has that blue button. You do deploy and test. So let's test this. Can anyone give me a sentence in English that belongs to one of the categories that I told you earlier? And let's try this out. Fast, fast. Or else I'm skipping. No one has an English sentence. Okay. I'll just put one image, one text. Just so. What do you think it will come, right? Sorry? Politics. Right? It's a bit of entertainment as well. So it knows. Come on. I need at least 2 questions, please. 2 texts. Yeah, please go ahead. आप तो पास ही हो.
Tom is a dog.
Huh?
Tom is a dog.
Tom is a dog. Okay. What do you think it will come to? Entertainment? Yeah. So it's 58% sure about entertainment. Let's see. Weird news. Right? It is a weird news. Nice. One more.
Dogs are better than cat.
ये तो सच है.
I have offended a lot of people.
I am not sure what will it belong to here. Let's see. Weird news. Okay, let's try something interesting, right? Give me a tech sentence, something like that. Yeah?
Google Cloud is better than AWS.
Okay. I'm sure it will come to tech. So business, right? And tech. So do you think this is very powerful? I've done nothing. I've just imported 10,000 text, and if you have built a model, 10,000 is really less. There are millions, 7 million data points that you give, and then you're able to actually build something so good. Okay, so I'll just go to the last one, which is it a dog or a cat image? Again, the same interface, deploy your endpoint, you try your uploaded image, you upload your image. What should I try? Dog. Lot of tag fans. Okay, so it is 85% dog. Do you think? 85% is the prediction, confidence. How sure is he about the dog? Anything above 60% is good enough.
Let's try a human image.
I do not have that currently, and it's not been trained. But let's say I put my 10 images, I put your 10 images, and I train it, and I then put my 11th image which has not been inserted, and I label this Vaibhav, and sorry, what is your name? So Harsh, and I label this Harsh and Vaibhav. It will be able to understand, okay, this image belongs to Harsh. So it's the same thing. You can do that. Nothing is stopping you from doing it. Okay, so that ends my talk. Was it interesting? Good? No? Yeah, you have any question? Yeah, sure.
I want to pursue my career in artificial intelligence and machine learning, but as a second year student, I don't know where to start and how to start. So can you guide us?
I think this is a good question we can take offline. If there is a question that you have specific to talk, I think I'll be, yeah, sure. Let's talk offline, definitely. Anyone have any questions specific to the talk? I'm around here. I'm still there till 6 p.m. So, and I have to leave then. So please ask me all those questions later on. And you can always connect with me on my LinkedIn. I generally reply in a day. Okay, so that ends the topic. Thank you everyone. You have been a great audience.
Thank you so much, Weber, for such an engaging session on, machine learning, which is very trending these days. Okay, coming up next, we have another speaker, Samir Khan, who will be giving a session on the nitty-gritty of using cloud PubSub to scale microservices.
Alright, talking more about Samir Khan. He works at the Internet Folks. Well, he's the organizer of Google Developers Group Bhopal. So, a cheer for that again. And yeah, he talks about startups, community, philosophy, and technology. So, I'm much awaited to hear for the next speaker.
Yes.
By the way, guys, are you enjoying the session?
Yes.
How many of you are not?
पहले डिज़ाइन करो, फिर डेवलप करो, फिर डिप्लॉय करो. That's what architect plus SWE plus SRE means. SRE is Site Reliability Engineer. I'm also the organizer at Google Developers Group Bhopal. And in the past 1.5 years, I deployed about 20 plus microservices, which is a debatable number because the concept of microservice में आप numbers कैसे ला सकते हो? I could make granular and absolutely not easy to use microservice and increase that number. So that number carries no weight except the fact that कि थोड़ा experience है, ठीक है? And more about me at Mumford, ठीक है? So before we begin this session, I wanted you guys to cheer for the organizing team of Cloud Community Days. Right? It's really hard to organize a session that does not exist in a place like Bhopal. So that was the cheers for. Now DevFest is coming. DevFest is just like Cloud Community Days but for all developers. ठीक है? ठीक है, cheers for that. ठीक है. Now getting back to the topic, DevFest. And this is what I have thought my DevFest team would look like, ideally. थोड़ा marketing वाले, थोड़े venue management वाले, थोड़े sponsors, but थोड़े generic management, organizers, leads. सही है? Started ऐसे होना चाहिए. But 3 months before the DevFest, we are like सब figure out हो रहा है धीरे धीरे. So we don't have any marketing, we don't have any management. Venue ढूंढना बहुत ज़रूरी है और sponsors ढूंढना बहुत ज़रूरी है. ठीक है? Cut to 1 month before. Venue थोड़ा सा final हो गया है, sponsors थोड़े से आ गए हैं, management ठीक ठाक हो रहा है और marketing ज़ोरों शोरों से चालू है. सब register करोगे DevFest में, ठीक है? हाँ? ये this is 1 month before, 7 days before. When you sorted तो कोई टीम नहीं बची उसकी, पर मार्केटिंग बहुत ज़्यादा करनी है. स्पॉन्सर्स के लिए 1-2 लोग हैं अभी भी who are looking out for, and management is the most important thing that is going on. ठीक है? Understandable, right? But what happened to my ideal team, yeah? I was supposed to be equal towards everyone. But is that the case? नहीं, ज़रूरत नहीं है. 3 month पहले marketing क्या करूँगा मैं? आज DevFest up, like we are going to hopefully announce today. इसके 10 दिन पहले तक के did you care about it? नहीं, CCD हो रहा है, it's good, right? 7 days before, I definitely need marketing. I want every developer to be involved, right? So why do I need a venue or sponsors वाली team? ठीक है? Sorted है? Is it logical? Does it make sense? Yes? ठीक है, so I think जब DevFest और CCD हो रहा है, everybody is talking to everybody. You have some friends in the organizing team who are in marketing or graphic designing, but you want a ticket. कौन लोग हैं जिनके पास टिकट नहीं थी और किसी से मिली या आ गए या लकीली मिल गई टिकट और आ गए? This guy gets this folks over here. ठीक है. It's chaos. If like तुम चाह रहे हो बात कर रहे हो, 10 ग्रुप है, कुछ दोस्तों से बात हो रही है, ऑर्गेनाइजर्स को DMs आ रहे हैं, Instagram पे DMs आ रहे हैं, emails आ रहे हैं, LinkedIn पे emails आ रहे हैं, DMs. It's chaos. Thankfully, we have a management team, which is what our organizers did. एक management team है, आप सीधे वेबसाइट पे जाओ, bhopal.cloudcommunitydays.in, सब लोग वहीं से रजिस्टर हुए थे, सही है? वो नहीं होता तो फिर क्या करते? मेरे को मैसेज आता है, इनको मैसेज आता है, क्रू को मैसेज आता है, राइट? तो thankfully, thank God we have management team, thank God we have a website, सही है? तो from this chaos, we went to a very simplified thing. समझ में आ रहा है? Does it make sense? I think it makes sense. वेबसाइट कौन कौन बना सकता है? I think you get it. क्यों important है वो? I see no difference between this and microservices, and I'll show you how. I'll not change any picture, I'll just change the label. This is a monolith which is not a microservice. इसमें क्या होता है? You have products, orders, users, notifications, सब है, ठीक है? Make sense? This is what happens on हर घर iPhone योजना. दो दिवसीय हर घर iPhone योजना में जिसने भी. Ideally, it should have been like this. सब कुछ important है. User sign up ही नहीं कर पा रहा तो कैसे order करेगा? Make sense? But microservice में, on a good day, इतने orders आ रहे होते हैं, नहीं? But सबको iPhone चाहिए तो product एक दिन खोल के तो सभी देख रहे हैं, है ना? सब देख रहे हैं खोल के, ठीक है? Notification भी इतने नहीं जा रहे क्योंकि कोई order ही नहीं कर रहा और sign up भी कम ही हो रहा है, ठीक है? What happens on Big Billion Day? सब order कर रहे हैं, ढेर सारे notification जा रहे हैं, support को messages जा रहे हैं, product तो लोग देख ही रहे थे और ज़्यादा देख रहे हैं. Make sense? This is where cloud pub-subs comes in. अब ये चार अलग चीज़ें हैं. अब मैंने देखो यहाँ कोई arrow नहीं बनाया. How are they talking to each other? It becomes something like this. I probably have a picture. I think मैंने इसको सीधे ही डाल दिया. But if cloud pub-sub was not there, it would have been chaos. और iPhone नहीं मिलता किसी को. Make sense? क्यों? Because अभी जैसे नेट स्लो था, ठीक है, नेट फास्ट भी हो तो it at least takes a second or 500 millisecond to make a request. अब हर सर्विस एक दूसरे को बोल रही है, देखो ऑर्डर्स वालों प्रोडक्ट का ऑर्डर आ गया है, ऑर्डर वाले बोल रहे हैं नोटिफिकेशन वालों ईमेल भेजो, SMS भेजो, लिंक्डइन पे DM करो, ऑर्डर आ रहा है, ठीक है? ऑर्डर वाले वेयर हाउस को बोल रहे हैं कि ऑर्डर आ रहा है. ये कितनी बातें हो रही, कितनी चैटर हो रहा है, किसको आइडिया है? अब कल गलती से ऑर्डर वालों ने काम बंद कर दिया, अब क्या होगा? नोबडी नोस, किसी का ऑर्डर नहीं आ रहा. यहाँ से एक लेयर गायब ही हो गई बातचीत की. कट टू अ माइक्रो सर्विस आर्किटेक्चर जहाँ पे जितनी ज़रूरत है उतना ही स्केलिंग हो रही है. जिस दिन ऑर्डर ज़्यादा हुए उस दिन ऑर्डर सर्विस चलेगी, जिस दिन प्रोडक्ट ज़्यादा दिखाए जा रहे हैं उस दिन प्रोडक्ट की सर्विस चलेगी, जिस दिन नोटिफिकेशन ज़्यादा जा रहे हैं उस दिन नोटिफिकेशन की सर्विस ज़्यादा चलेगी, ठीक है? अब ये क्लाउड पब-सब क्या है? वाई इज़ दिस हियर? मैं तो माइक्रो सर्विसेज बता रहा था, राइट? तो पब-सब इज़ बेसिकली द कम्युनिकेशन लाइक चैनल बिटवीन दिस सर्विसेज, ठीक है? प्रोडक्ट, ऑर्डर्स, यूजर्स, ठीक है? इन सब के बीच में बातचीत करने के लिए कोई मीडियम चाहिए. अगर ये एक दूसरे से बात करेंगे तो कभी कोई कोऑर्डिनेटेड ही नहीं रह पाएगा. मैंने एक क्रू मेंबर को बोल दिया कि आई नीड दिस एंड दे आर ऑफ टू गेट इट, और फिर मैंने दूसरे को भी बोल दिया यार आई रियली नीड इट, और वो दोनों एक ही चीज़ कर रहे हैं और पता चला दोनों ही वो चीज़ ले और मुझे एक ही ज़रूरत थी. नाउ द अदर वंस एफर्ट एंड दे थिंक इज अ वेस्ट. मेक सेंस? यानी कोऑर्डिनेशन चाहिए. इफ़ यू वुड हैव नॉट बीन हियर, अगर तुम्हें ईमेल्स नहीं आते, कैसे आते तुम यहाँ तक के, राइट? आधों को वेन्यू नहीं पता होता, आधों को बस टिकट नहीं होता. वी ऑल नीड सम कम्युनिकेशन चैनल बिटवीन अस, राइट? राइट? तो पब-सब फॉर माइक्रो सर्विसेज इज दैट चैनल, ठीक है? आई स्किप्ड ऑन द कॉन्सेप्ट ऑफ माइक्रो सर्विसेज एंटायरली ताकि मैं सीधे प्रैक्टिकली दिखा पाऊँ. But even like any of you are not able to grasp this, you'll be able to understand it better. If you realize, थोड़ा सा contrast सही नहीं होगा, there is all gray area here. It's all gray. It means it is a part of the whole big thing. एक लैंग्वेज में आपने लिख दिया, एक एक्सप्रेस ऐप में, एक फ्लास्क ऐप में आपने लिख दिया, and it's all running from there. I didn't use that in the microservices. I have left out space, which means कि आप प्रोडक्ट फ्लास्क में पाइथन में लिख सकते हो और ऑर्डर्स वाली सर्विस Node.js जावास्क्रिप्ट में लिख सकते हो, ठीक है? ओके, हाउ डज इट मेक सेंस? ये लोग बात से कैसे करेंगे एक दूसरे से? पब-सब को फ्लास्क भी समझ में आता है, पब-सब को Node.js भी समझ में आता है, और इसलिए नहीं क्योंकि पब-सब को बहुत लैंग्वेजेस आती है और वो भयंकर कोडर है. पब-सब बातें करता है जेसन में. जेसन सबको समझ में आता है, अच्छा मुझे एक बार शो ऑफ हैंड से बताओ, हु वर्क्स इन पाइथन, हु वर्क्स इन नोड.js, हु वर्क्स इन गोलैंग, सम पीपल। जेसन सबको समझ में आता है, लेकिन जेसन सबको समझ में आता है। सो इफ आई जस्ट मेक दिस कम्युनिकेशन इन जेसन, सब बात कर लेंगे, ठीक है। किसी को गुजराती आती है, किसी को मराठी आती है, हिंदी ऑलमोस्ट कॉमन लैंग्वेज है, इंग्लिश ऑलमोस्ट कॉमन लैंग्वेज है, ठीक है। बाहर जाओ अब्रॉड में, यू कैन टॉक टू कॉमन लैंग्वेज, भले से यू कम फ्रॉम अ डिफरेंट कल्चर, राइट। PubSub makes this cross service communication easy, ठीक है। It's very magical. Now you can have a person who's promoting Golang all the time like me, and you can have a Pythonista who is not ready to go away from Python, and they both can work in the same team. एक को बोल दो प्रोडक्ट बनाओ, एक को बोल दो ऑर्डर बनाओ। बातचीत कैसे होने वाली है? जेसन से। अब सब तो मतलब चैनल है। इट्स लाइक सेइंग के ईमेल तो सब कर रहे हैं, बट उसमें लिखा क्या है? इंग्लिश लिखिए ना, वैसे। इंग्लिश इज द लैंग्वेज, ईमेल इज द मीडियम, PubSub इज द मीडियम, जेसन इज द लैंग्वेज। एंड इट्स नॉट इंटायरली ट्रू। प्रोटोबफ जो कि gRPC का भी बेस है, वो भी इसमें सपोर्ट होती है, बट ऑन अ वेरी हायर लेवल जेसन इज सपोर्टेड। सो अब ये कम्युनिकेशन का जो गैप है, ये किसने फिल कर दिया? PubSub ने। अब बिग बिलियन डे के दिन क्या हो रहा था कि ऑर्डर्स बहुत ज़्यादा आ रहे, यूज़र साइन अप कम कर रहे होंगे फॉर सम वियर्ड रीज़न, मैं ऐसे ही बोल रहा हूँ, हो सकता है उस दिन साइन अप ज़्यादा, इनफैक्ट सभी ज़्यादा होगा, बट लेट्स अज्यूम कि यूज़र साइन अप कम है बट ऑर्डर ज़्यादा है, एग्जिस्टिंग यूज़र बहुत खर्चा कर रहे हैं। तो दिस इंडिविजुअल पाइथन और गो और जावास्क्रिप्ट सर्विस कैन स्केल। वो स्केल कैसे करती है, वी कैन टॉक अबाउट दैट, दिस इज़ नॉट व्हाट दिस टॉक इज़ अबाउट। Microservice काफ़ी इंटरेस्टिंग कॉन्सेप्ट है, इफ़ यू वांट टू लर्न मोर वी कैन ऑब्वियसली टॉक ऑफलाइन ऑन दैट। बट ऐसे अज्यूम कर लो कि जैसे मार्केटिंग वाला आइडिया था, सम डेज द वेन्यू टीम इज ऑन हाई अलर्ट, सम डेज मार्केटिंग टीम वाज API सब बनाते हैं। PubSub इज द मीडियम, जेसन इज द लैंग्वेज, ठीक है। ये लास्ट वाले पॉइंट से कुछ कि हम लोग इमीडिएटली ये पता लगा सकते हैं कि अगर वैकेंसी है कि नहीं सीट की। मेक सेंस? सब कोऑर्डिनेटेड है यानी, मेक सेंस, ठीक है। द बेनिफिट्स ऑफ PubSub यू हैव सीन, इंडिपेंडेंटली स्केल कर लो, क्योंकि फ़र्क ही नहीं पड़ता कि आपकी एक सर्विस किस में बनी, आपकी एक सर्विस किस में बनी, बातें किस में करनी है, जेसन में करनी है, तो कोई फ़र्क ही नहीं पड़ेगा। सिंपलर कम्युनिकेशन कैसे होगी? मुझे सिर्फ वेबसाइट चलानी आनी चाहिए, मुझे Node.js आना चाहिए क्या गो वाले को? क्या Node.js वाले को गो आना चाहिए? गो वाले को Node.js आना चाहिए? क्या आना चाहिए? जेसन आना चाहिए। जेसन तो सबको आती है ना? आती है, ठीक है। रियल टाइम होता है, ऑलमोस्ट रियल टाइम होता है। आई हैव नॉट रिटन द वर्ड ऑलमोस्ट, बट इट्स ऑलमोस्ट रियल टाइम। यू कैन कॉन्फ़िगर इट टू बी ऑलमोस्ट रियल टाइम। जैसे ही मैंने वेबसाइट पे टिकट खरीदी, उसी टाइम मुझे पता चल जाएगा कि वो कंफर्म हो गई कि। दैट्स द काइंड ऑफ पावर इट हैज़। And separation of concern, which is across teams लिखा है by the way. Separation of concern समझ में आता है? It's a very theoretical aspect, we don't have to talk about it, but separation of concerns किसी को समझ में आता है? If anyone wants to raise their hand, नहीं? Separation of concerns तो कोई बड़ा टॉपिक नहीं। Separation of concerns means तुम तुम्हारा देखो, हम हमारा देखेंगे। हमको मार्केटिंग करनी है, मार्केटिंग अच्छे से करेंगे, तुम्हें स्पॉन्सरशिप लानी, तुम स्पॉन्सरशिप लाओ, मैं तुम में दखल नहीं दूंगा, तुम मेरे काम में दखल नहीं होगी। आ गया? ठीक है, यही है। और एट द एंड ऑफ द डे कम्युनिकेशन करना है, वो किस में कर रहे हैं, किसके थ्रू कर रहे हैं? सिंपल है, मैं मेरा कुछ भी काम कर लूँ, एट द एंड ऑफ द डे आई विल गिव यू द रिजल्ट एंड यू विल अंडरस्टैंड इट, नो मैटर हाउ आई वर्क। यूज केस ऑफ PubSub एक माइक्रो सर्विस का तो बना ही दिया। जो चीज़ बोली मैंने, इवेंट बस, दैट इज व्हाट द थिंग इज, लाइक द कॉमन कम्युनिकेशन चैनल। डेटा स्ट्रीमिंग में भी ऑन ऐड टू कार्ट बटन, बट यू डोंट बाय द प्रोडक्ट, फिर भी इंस्टाग्राम पे दिखने लग जाता है। आजकल तो मियरली बात करने से ही वो हर जगह दिखने लग जाता है। मेरा कोवर्कर है, उसको तो डर लगता है बात करने में, वो गलती से किसी के साथ बात भी के रजिस्टर का बटन ही नहीं दिख रहा है। हो सकता है वो इतना नीचे का कोई जा ही नहीं रहा है, ठीक है। अब सब लोग रजिस्टर कर रहे हैं बट किसी का टिकट ही नहीं आ रहा है। तो मुझे पता है कि फ्रंट एंड से तो हो रहा है, बैक एंड में कुछ दिक्कत है। मेक सेंस? पैरेलल प्रोसेसिंग तो समझ में आ गई। पैरेलल प्रोसेसिंग का सिंपल सा फंडा, ऑर्डर प्लेस करा, क्या क्या चीज़ें होती है, पेमेंट प्रोसेस होती है, ईमेल जाता है, वेयर हाउस डिलीवरी वालों को भी मैसेज जाता है कि ये ऑर्डर बुक हो चुका है, अब स्टॉक को कम कर दो। 3 चीज़ें हो रही है। अब ये 3 चीज़ें करने के बाद अगर तुम्हें फाइनली सक्सेस मैसेज दिखता तो कितना वेट करना पड़ता? बाय नाउ क्लिक करा, 2 घंटे बाद आया, हाँ भैया हो गया। बट अपन को कैसे दिख जाता है? इंस्टेंटली। कैसे? बाय नाउ आ गया आईफोन, डिलीवरी डेट आ जाती है ना? दैट्स व्हाट पैरेलल प्रोसेसिंग इज। उसने एक को बोल दिया ये कर लो, एक को बोल दिया ये कर लो, एक को ये बोल दिया। इसका काम है क्या? नोटिफिकेशन भेजना। नहीं भेजेगा, वो बोल दिया, वो करता रहेगा। उसके जब वो कर देगा मुझे पता चल जाएगा। तो दिस इज़ व्हाट आल्सो हैपेंस इन पबसब। मैंने उस सर्विस को बोला ये कर दो, मैंने ये नहीं बोला कैसे करोगे, सिर्फ क्या बोला, ये कर दो। मार्केटिंग वालों को बोला, मैं स्पॉन्सर वाला हूँ, कि एक अच्छा सा फोटो भेज दो डेफरेस का। उन्होंने भेज दिया। कहाँ बनाया है? फोटोशॉप, कैनवा, आई डोंट केयर, है ना? आउटकम से मैटर करता है। तो पैरेलल प्रोसेसिंग में ये हो जाता है कि जब वो कर देगा वो मुझे बता देगा, ताकि मैं अपनी चीज़ें अपडेट कर दूँ कि हाँ मेरी स्पॉन्सरशिप की डील रुकी हुई है बिकॉज मार्केटिंग से एक फ़ोटो नहीं आया, वो भेज देंगे, मैं आगे प्रोसेस कर दूँगा। मैं वेट नहीं करूँगा, मैं अपना काम और कर रहा हूँ, मेरे पास और भी काम है। मेक सेंस? पैरेलल प्रोसेसिंग। अब आता है क्लाउड पबसब। क्यों क्लाउड पबसब निकाला? और मैं पबसब ही क्यों बोल रहा था अभी तक, कि क्लाउड क्यों यूज़ नहीं कर रहा था? पबसब इज़ नॉट अ प्रोप्राइटरी टेक्नोलॉजी, ओपन सोर्स भी है। काफ्का का नाम किसी ने सुना है? काफ्का का सुना है? SQS, AWS SQS, SNS, सिंपल क्यू सर्विस, सिंपल नोटिफिकेशन सर्विस, ठीक है। काफ्का सुना है, ये सुना आई थिंक। इसके बाद तो क्लाउड पबसब भी है। उसके अलावा मेजर प्लेयर्स RabbitMQ वैसे मैसेज किया हुआ, बट ठीक है, सुना है ना? Cloud PubSub, I like it the most and I use it for my microservices simply because it's managed by Google. तो वो जो headache है खुद से configure करने का, it's gone. It's very cheap to use and it has many benefits. जैसे exact once delivery. पेमेंट हो गई, आईफोन भेज दो, मैंने ऑर्डर वालों को भेजा। पेमेंट हो गई, आईफोन भेज दो, मैंने ऑर्डर वालों को भेजा। दो चले गए, 2 आईफोन पहुंच जाएंगे, मेरा तो घाटा हो गया जस्ट बिकॉज मैंने उसको गलती से 2 बार बोल दिया। समटाइम्स यू कैन नॉट अफोर्ड दैट, लिटरली कैन नॉट अफोर्ड दैट। तो उसको कॉन्टेक्स्ट पता है, तो दैट्स वेयर ऑर्डर डिलीवरी इज इम्पॉर्टेंट। ठीक है। एक्सपोनेंशियल रीट्राई पॉलिसी विद दैट लेटर क्यू, ओ माय गॉड, we'll break it down. Eat a whale one bite at a time. Exponential retry policy. पेमेंट हो गई है, व्हाट्सएप पे एक टिक, बंदा ऑफलाइन है बट मैसेज पहुंचाना है, थोड़ी देर से ट्राई कर, तो 5 मिनट बाद पेमेंट हो गई है, सिंगल टिक, चलो ठीक है, पिक्चर देख रहा है, आधे घंटे बाद पेमेंट हो गई है, अभी भी ऑफलाइन है, कहाँ है भाई? ठीक है, 3 घंटे बाद बोलता अरे पेमेंट हो गई है, कोई रिप्लाई नहीं आ रहा। 1 दिन बाद बोला फिर मैंने, भाई पेमेंट हो गई, हाँ भाई ठीक है, एक्नॉलेज। तो ये एक्सपोनेंशियल रीट्राई। अब हर 5 मिनट में बार बार उसको बोलने का क्या मतलब है? पहले 5 मिनट, 10 मिनट, आधा घंटा, 1 घंटा, 3 घंटा, 1 दिन, 7 दिन, मतलब बीच में 3-5 दिन भी हो सकते हैं, बट दैट्स व्हाट एक्सपोनेंशियल रीट्राई मीन्स। मैसेज भेजना ज़रूरी है, उसने तो पेमेंट कर दी, उसको लग रहा है आईफोन आ रहा है, पता चला जिस दिन आईफोन आना चाहिए था उस दिन तो मैसेज ही नहीं पहुंचा, तो रीट्राई तो करना पड़ेगा। अब ऑर्डर वालों के पास बहुत ज़्यादा लोड है अभी काम का, तो हो सकता है उनको मैसेज नहीं मिला, तो अपन रीट्राई करते हैं। डेड लेटर क्यू क्या है? अब उसने 7 दिन बाद भी मैसेज नहीं देखा, जॉब ही छोड़ दी उसने, फिर क्या करोगे? कंज्यूमर ने तो पेमेंट करी है, उसको तो चाहिए। तो डेड लेटर क्यू इज जस्ट द क्यू ऑफ ऑल योर डेड मैसेजेस जो कि पहुंचा ही नहीं जा सके, तो जब दूसरे बंदे को हायर कर लेना, ये सारे मैसेज पहुंचा देना, तो वो सब काम कर देगा। मेक सेंस? मेक सेंस? यस, सही है। और सबसे इजी चीज़, आई डोंट हैव टू वरी अबाउट स्केलेबिलिटी, इट्स फुली मैनेज्ड बाय गूगल। 1 मिलियन मैसेजेस पर सेकेंड, तो वो ऐसे ही बोस्ट करते हैं। इट्स ऑब्वियसली मोर स्केलेबल देन दैट। और ऑटोमेटिकली अगर आज 1000 लोग हैं, कल 1 लाख लोग हैं, एंड इट कैन हैपन, तो मेरा माइक्रो सर्विस तो स्केल कर जाएगी, मेरे को पता है कि कल मार्केटिंग की ज़रूरत नहीं, आज है तो कल वाले बंदों को मैं आज ले आऊँगा, बट बीच में ऑर्गेनाइजर तो एक ही है, डेफेस तो गया फिर नहीं, इसलिए तो क्रू रखते हैं. ऑल ऑफ देम आर मैनेजमेंट, दे कैन हेल्प कोऑर्डिनेट दिस होल बिग इंफ्रास्ट्रक्चर एंड आई कैन नॉट रिलाई ऑन समथिंग दैट आई हैव कॉन्फ़िगर्ड. तो मैं गूगल को बोल देता हूँ, दे कैन स्केल इट इंस्टेंटली और मैनेज्ड है, आई डोंट हैव टू वरी. Now how does Cloud PubSub work? This is थोड़ा सा टेक्निकल. तो पेमेंट हो गई है, कोई इंग्लिश में क्या बोलेंगे, पेमेंट प्रोसेस, ये टॉपिक हो गया. किसने बोला? मैं हूँ, जो प्रोडक्ट सर्विस थी, मैंने बोला पेमेंट प्रोसेस हो गया. तो आई एम द पब्लिशर, ठीक है. पेमेंट प्रोडक्ट, पेमेंट प्रोसेस, ये टॉपिक है. अब इसको सुनने वाले जितने लोग हैं वो सब सब्सक्राइबर हैं. कौन कौन सुनेगा? नोटिफिकेशन सर्विस, उसको SMS भेजना है, वेयर हाउस वाली सर्विस क्योंकि उन्हें एक आईफोन रखना है गाड़ी में, है ना. डिलीवरी वाली सर्विस, उनको चाहिए कि उस दिन डिलीवरी बॉय अवेलेबल हो, ठीक है. सिंपल से ये पब्लिशर सब्सक्राइबर, पब्लिशर सब्सक्राइबर. और ज़्यादा इजी एग्जांपल, यूट्यूब चैनल्स, सब्सक्राइबर्स. मैं पब्लिश करता हूँ, तुम लोग सब्सक्राइब करके बैठो. अब मैंने पब्लिश करा, तुमने बेल आइकन दबाई है, और जो लाइव चल रहा है उन्होंने भी दबाई होगी होपफुली, तो उनके पास नोटिफिकेशन गई होगी, उनके पास ही गई, सबके पास तो नहीं गई. यूट्यूब तो इतना बड़ा 2 बिलियन उनका है, बिकॉज दे हैव सब्सक्राइब्ड. किससे सब्सक्राइब? कि न्यू वीडियो आए तो नोटिफिकेशन आ जाए. दैट्स द टॉपिक, दीज आर द सब्सक्राइबर्स, आई एम द पब्लिशर. मेक सेंस? ठीक है. इसको मैंने Node.js में करने का एक सिंपल सा तरीका बताया. ये बस एक फ्लो डायग्राम है, हाउ इट वर्क्स. बीच में एक्चुअली गूगल को मैसेज स्टोर भी करना पड़ता है, क्योंकि पहुंचाया ही नहीं तो फिर मैं छोड़ तो नहीं दूंगा. मेरे को बार बार पहुंचाना है मैसेज आपका, तो मैं स्टोर कर लेता हूँ. ये एक तरीका है. इट्स वेरी सिंपल, बाय द वे, इट्स वेरी सिंपल. यू कैन जस्ट सी, आई एम जस्ट इम्पोर्टिंग एंड देन क्रिएटिंग द टॉपिक, द क्रिएटिंग द सब्सक्रिप्शन. मतलब आप लोगों ने सब्सक्राइब करा तो वो सब्सक्राइबर आप बन गए. मेक सेंस? पब्लिशिंग द मैसेज कि नई वीडियो आ गई है. इट्स वेरी इजी. आई जस्ट यूज द टॉपिक्स नेम, जो कि चैनल का नाम हो सकता है, एंड आई जस्ट पब्लिश द मैसेज, जो कि हो सकता है वीडियो की आईडी. मेक सेंस? मेक सेंस? थोड़ा सा आई नो, बट ऊपर ऊपर लेवल से. Node.js नहीं आती, इट्स टोटली ओके. इट्स अवेलेबल इन ऑल लैंग्वेजेस होपफुली. एंड यू आर द सब्सक्राइबर, यू आर लिसनिंग फॉर न्यू मैसेजेस, न्यू वीडियोज़. जिस दिन आ जाएगी वी विल इंस्टेंटली प्ले. ठीक है. The code samples can be, taken down later as well. ये सब docs से ही उठाए मैंने. I have not written them down. This is the example of what I was telling you. Order service ने order created बोला, कुछ data भी भेजना है. किसका order है? तो उसने लिखा order number 1 है, product number 4 है, इस पिन कोड पे जाएगा, इस फ़ोन नंबर पे जाएगा. फ़ोन पे कॉल करने की कोई ज़रूरत नहीं, आइडिया का कस्टमर केयर नंबर है. Now the nitty-gritty, and this is just 5-minute thing. ये context set करना 90% टाइम लग जाता है, just to tell you the nitty-gritty. और ये thought experiment, ठीक है. I've listed down some terms here. I'll tell you, और सिर्फ 5 minutes में ये cover हो जाएगा. You just have to stay with me. Is everyone alive? ठीक है. Ordering सबसे खतरनाक चीज़ है. अगर ऑर्डर करनी है, and now imagine at the level of 1 million messages per second, per day नहीं, उसमें ऑर्डरिंग करना is very costly because you have to assign an ID to everyone, और वो ID किसी और को नहीं जानी चाहिए. 1 मिलियन में 1 सेकंड में आपको ढूंढना पड़ेगा वैसा. मेक सेंस? इट्स अ चैलेंज. मेक सेंस? आज मैं नंबर 1 हूँ. IRCTC में जो होता है कि अपन दोनों ने साथ में बुक कर ली, अब किसको मिलेगा पहले? इट्स अ चैलेंज. किसी ने कभी देखा है कि 2 लोग एक ही सीट पे आ गए हो, सेम डेट सेम ट्रेन? नहीं देखा? मोस्टली नहीं होगा, मैंने भी नहीं देखा. होपफुली जिस दिन पता चले मुझे भी बताना. आई विल टेल देम क्लाउड पब्सब. ठीक है. बट हाउ इज इट पॉसिबल? बिकॉज दे हैव सॉल्व्ड ऑर्डरिंग. सिमिलरली दे हैव सॉल्व्ड ऑर्डरिंग एज वेल. इट्स जस्ट आपकी एफिशिएंसी कम हो जाती है. आपको डिसाइड करने में टाइम लगता है कि ऑर्डर नंबर क्या देना है. मेक सेंस? पुल और पुश ये थोड़ा टेक्निकल है, वी कैन स्किप दिस. बट इसमें बेसिकली डिसीजन ये लेना होता है कि Do you want to receive this message 10 seconds बाद या instantly? और ये सोचना को obviously instantly चाहिए, but it's not always the case. Instantly में you always have to be available. Pull में you can just poll it. Poll अगर आपको पता हो तो you can read more about it. It's very interesting. थोड़ा सा technical detail है इसलिए I'll skip over it. Cost versus latency. The term you'll hear in every talk. Cost. We have to minimize cost. क्योंकि फालतू में कुछ रिसोर्स यूज हो रहा है, इट्स नॉट गुड. लेटेंसी पता है किसी को? लेटेंसी डिले राइट. ओहो अच्छा, पबजी वाले. हाँ समझ गया. थैंक गॉड. अब द वे पबसब इज मेड, या तो आपकी कॉस्ट कम होगी या तो आपकी लेटेंसी कम होगी. कैसे? पेमेंट हो गया 10 बार बोलो, इससे अच्छा मैं एक बार बोल दूंगा कि ये 10 लोगों का पेमेंट हो गया. मेक सेंस? मैं एक बार में भेज दिया कि ये 10 लोगों का पेमेंट हो गया. मेक सेंस? बट जब तक कि 10वें का नहीं हो जाता मुझे रुकना पड़ेगा बोलने के लिए, क्योंकि मैं 10 लोगों का ही बोल रहा हूँ, तो समय लगा. बट अगर मैं इंस्टेंटली बोल देता तो वो क्या है, कॉस्ट बढ़ जाती है उससे, बिकॉज उसको काम करना पड़ रहा है इंस्टेंट के लिए. तो लेटेंसी वर्सेस कॉस्ट समझ आया है ना? इट मेक सेंस. या तो मैं वेट करूँ 10वें के लिए, या तो इंस्टेंटली एक का कर दूँ. ठीक है. क्लाउड तो बोलेगा कि यार आपने एक मैसेज भेजा उसको तो पैसे लगेंगे, आप 10 में एक को भेज दो तो भी चलेगा. एक्नॉलेजमेंट डेडलाइन, ये सबसे बेकार है. इसकी वजह से ही मैंने टॉक ये रखी थी कि मेरे को इस पर बोलना है. एक्नॉलेजमेंट डेडलाइन इज कि मेरे पास मैसेज आया, पेमेंट हो गई, मैं उसकी प्रोसेसिंग करूँगा और बोल दूँगा हाँ ठीक है मैंने इसको प्रोसेस कर लिया. वो भाई वेट ही नहीं करते, वो निकल जाते हैं दूसरे को बोलने, अरे पेमेंट हो गई क्या करना है, अब मैं प्रोसेस कर चुका हूँ. तो ये एक प्रॉब्लम आती है कि आपने अगर एक्नॉलेजमेंट डेडलाइन बहुत छोटी रख दी तो इट विल नॉट वेट फॉर यू टू प्रोसेस दी होल थिंग. ठीक है. डुप्लीकेशन रेट, ये भी एक प्रॉब्लम है. आपने 2 ही मैसेज 2 बार भेज दिए, एक मैसेज जो होना चाहिए था, तो यू हैव नाउ एसेंशियली कॉस्ट योर सेल्फ सम रियल बिग अमाउंट. ठीक है. आई विल कम बैक. ये 5 चीज़ें थोड़ा सा ऊपर से है, बट डिड यू गेट द लॉजिकल पॉइंट ऑफ इट? यस सही है. नाउ दिस इज अ वेरी गुड कोट. जब भी आपको बड़े इसकी सिस्टम बनाने, यू विल ऑलवेज कम बैक टू दिस कोट कि सॉफ्टवेयर इंजीनियरिंग इज ऑल अबाउट ट्रेड ऑफ्स. या तो कॉस्ट बचाओगे या तो लेटेंसी बचाओगे. समटाइम्स वेबसाइट्स आर स्लो बट देयर इज अ रीजन बिहाइंड दैट. ठीक है. मेरे को पढ़ना पड़ेगा क्या? नहीं है ना? सॉर्टेड है? ठीक है. आई होप यू मेक गुड ट्रेड ऑफ्स फॉर योर करियर. Thank you. If you have any questions and answers about the talk, you can just ask me right now. Any questions? सही है? समझ में आया सब कुछ? Thumbs up? Yes? Thank you. Thank you so much.
Thank you so much, Sameer, for such an engaging session. I saw everyone was enjoying this session really well. So, guys, we are taking a short break here. 5 minutes coffee tea break. Coffee and tea are at the back. Please help yourself. only. So Aditya Shah is basically the DevOps manager at InkSub LLC, and now we're going to have a fun session on how to configure Cloud CLI.
Hey, me again. Can I have the all, like everyone's voice, please? Or everyone is sleeping? नहीं सो रहे सब. I got to know. One second. Mics हो गया. Let me try this one. One second, huh? 1 minute. ऐसे आवाज आ रही है सबको? ऐसे समझे? Not much we can do. So okay, you might be wondering, like, all the sessions are like super techie, super duper awesome, but कुछ ऐसे होंगे ना सर के ऊपर से जा रहे होंगे, right? So I brought one of such topics, but वो उतने सर के ऊपर से नहीं जाएगा. So किसी ने यहाँ पे CLI का नाम सुना है? किसी को पता है CLI क्या होता है? कमांड लाइन इंटरफेस. कितने लोग यूज करते हैं? How many of you do use CLI? Great numbers. Like when I was in college, I was never using CLI. Well, I was afraid of using CLI because commands याद करने होते हैं. ठीक है? So before we begin, again let me introduce myself. My name is Aditya Shah and I work for a company called INC Sub. It's a US based company and I do a remote job. Like my friend Vaibhav told about remote job. Rohit told, right? So yeah, but then others are also there who do remote jobs unlike me. So yeah, that's a different thing. Okay, well, let's come to the topic. We'll talk about Google Cloud CLI because we are at Google Cloud Community Days. So, first of all, the question is why CLI? Does anyone know why CLI? Why should we use CLI? Yes, please.
CLI is easily and so fast working.
Easy and fast. Anyone else? Straightforward. Great. Sorry? Right, exactly, straightforward. Anyone else? Developer friendly.
Batch operation we can perform.
Sorry?
We can perform batch operation.
Batch operations. Great. Anyone else?
Control what होता है?
Control. Great. So that was okay. I wrote all of this right here. So you read this and then told me, oh, is that so?
No.
Okay. Anyways, but yeah, that's the thing. So it gives better control. Navigation in the GUI can be confusing. Better speed. Why? Because you don't need to load a lot of pages, browse through those, and you can just write a command and it will execute directly. Then it consumes less memory on the computer that you are running on. For example, if you load a page, it will require more memory to load that page. It will require some computation power. Whenever you do CLI, it just uses the command line interface, the CLI, the terminal or the CMD or whatever. So it uses a lot less memory compared to other things. Then you can do automation, like he said, you can perform batch operations. Batch operations as in, you want to create a server for your client and also want to deploy a Nginx server on that, deploy PHP, MySQL or whatever services, and then sell it to them. If you do this for every client, it will consume more time of yours. Like for example, you need to deploy 100 servers. You will need to go to Google Cloud CLI, Google Cloud, and then create a resource there, then deploy all of these services one by one, which will be a lot of time-taking things. What you can do is you can just create a bash script or something of that sort, deploy all of the commands there, and run that bash script. And again, to deploy 100, you can just write a for loop, for example, and run that bash script for 100 times. You can create just 100 servers. Is that sorted? One second, huh?
Hello.
Does it work?
Yes.
All right. The screen doesn't work. Okay. So where were we? So it gives automation thing, right? We can automate things from CLI. Now going to the other things. Now you'll ask me, like, does all of the cloud providers provide CLI? Like, can we perform all of these things in other cloud providers also? So yes. You have AWS, you have Azure, you have Linode, you have DigitalOcean, you have Vultr. All of these platforms provide their own CLI. So you can just install their SDK or install their tools and run the CLI directly from your terminal. Cool? Any doubts until here? No. So we'll follow our topic, that is Google Cloud CLI. So what do you need to do in order to use your Google Cloud CLI? Anyone?
Authenticate.
Authenticate?
Yes. Yes.
All right. But before authenticate, you'll need to install the CLI, right? So yeah. So you'll need to install the SDK first.
Hello.
I hate these things, but then I am a without mic person. It doesn't work. All right, that's not a problem. So where were we? We were on installation. So what we need to do to use the CLI is install it first, right? After you install, so if you don't install, you can also run it within the browser, but that doesn't make any sense because you need to automate things, right? If you need to automate things, you will need to have something on your local machine or on a server where you can deploy a batch or you can deploy, I don't know, any kind of automation. So installation, how do you install? You just download the SDK from here and then run the SS, that is bash script on your laptop or your computer, right? Now you will need to authenticate your Google account. So when it comes to authentication, you will be like, how will my terminal or my computer will know that I own this Google account? Like you might have 4 or 5 or let's say 10 Gmail accounts logged in on your browser. Which one to use? How will your CLI know? To do that, you will need to authenticate that in the terminal. How will you do that? Via this command, init command, right? Now after you authenticated, now your terminal knows that this is the account that I need to use. What you need to do is you need to configure the CLI. Configure as in you will need to set a project ID. Have you, like, how many of you have used Google Cloud? The native Google Cloud. This you people have used, right? So when you use it, you will see project ID there, project names. So these kind of things are there. This is project ID, this is project number. So when you want to use these, and like you need to use these in your project. For example, you need to create a virtual machine from your terminal. So you need to tell your terminal that I need to use this project ID. How will you do that? Do that again. It's easy. Again, one command, gcloud set project. Easy command. And then the name of the project. What was that? The name is here. This one. Okay? Easy? So far? So now, after you configured the CLI, what you need to do is you need to create a virtual machine, right? Why I configured this? To create a virtual machine. Now, when you want to create a virtual machine, it has a, so when you want to create a virtual machine, it asks for 2 things. What? One is the size, one is the region. Like these are the 2 things that matters. Because where you want to host it, it has like multiple data centers across the world. I want to set it up at Mumbai location in India, right? Because that's the nearest location. So I'll set it at Asia South A. No, it should be Bangalore location. But you can go to Google Cloud site and it will show you these kind of codes for each location. So you can set from there. Now, so similarly, like these are two locations that I have set here. Once this is done, now this is once you set the region. Even if you don't set the region, that's okay. Why? Because we can also pass this zone within the create instance. So when you want to create the virtual machine, you need to pass this command gcloud compute instance create. Like this is common for all. This is my virtual machine name. Getting it? So this is virtual machine name. Then machine type. Machine type is what? Like what size? The size matters. Why? Because according to the size, the cost will matter for the month, right? So what I do is I set up a E2 medium size virtual machine. Cool. Now I need to pass the zone. Zone means the location. So -- zone South Asia Southeast 2P. So that will be the Bangalore location, right? So once I do this, it will automatically create a virtual machine. How? Like this. What I did, I just typed this command, the first line. It will automatically create this. Now the name will be this, zone is this, machine type is this. Like it will show all of this information and will show it is running. Getting it? Yes. Now how to list instances? Again, the command is there. Again, a simple command. Now I have created the instance. I want to delete it. Let's see a demo. Quick and like fast. developer ever remembers anything. Like, you can, but nobody does. So we always go to Google, search for like what I want to do. This, like I know things, right? I can remember things, but then why? So I just copied it, and let's see. So I just pasted it, and what I will do is I will just change the name of the virtual machine. How? Like this. And as soon as I hit enter, it will automatically create the virtual machine for me. Yeah. So as soon as I hit the command, it automatically created the virtual machine for me. Like it was quick. Not even 1 minute, right? Whereas if you have created from here, it should have taken like 1 to 2 minutes, right? So this is how you can use the CLI for yourself and your projects, and you can use these kind of commands to run the batch processes. All good? That's it. Thank you. No? Cool. We'll see after the event, and we can meet. Cool. Bye bye.
Okay, thank you Aditya for such an interesting session on configuring Cloud CLI. Guys, we can have a applause for Aditya. Okay, next session is on getting started with Google Kubernetes Engine and Industry Insights, learning how Kubernetes automates operational tasks of container management. So this session is going to be presented by Ankit Patel. He is a senior software engineer at Mindtree, and he is really, very much into DevOps. So Kubernetes is one of the DevOps technology. CI/CD, Jenkins, pipeline, Terraform, Docker, everything on DevOps. So get ready to attend the session very, very, very cautiously.
I know you must all be tired by now, but don't worry. I will be just covering the basic of Kubernetes and how you can get started with the Google Kubernetes engine quickly. So let me just introduce myself first. I am Ankit Patel, working as a DevOps engineer in Mindtree. Where I am previously working as a Java developer, but then later I got an opportunity to work into the cloud, and since around past 3 years I have been working with the Google Cloud platform and different technologies. I will. So let's just introduce today's talk, that is the getting started with GKE and how we can automate things using the Google Kubernetes engine, where I will also show you the live demo, how you can quickly deploy the sample Hello app into the Google Kubernetes engine, where internet users can access. So let's just begin. Before we begin, may I ask a question with all of you? How many of you are aware about the Kubernetes? Okay. So, do you know what does Kubernetes mean? Anyone? Okay.
Yes, please.
So let me just go through. Kubernetes is nothing but is in a Greek word, it is called as for a pilot, called the helmsman of the ship. That is nothing but the one who drives the ship. In the similar manner, we can compare Kubernetes with our today's IT world, called where Kubernetes acts as a master component which can orchestrate the deployment of those containers or images which you will develop using the Docker. So this is the why we should learn Kubernetes in this modern IT industry, where everything people are looking for automate the things. So Kubernetes will surely will keep you upfront beneath all the technologies which we currently using. So that is the most highly demanding tool in the market, which we can deploy with different images, public images as well as the private images, which has been hosted on the Docker private registry. So what is Kubernetes? That is simply a container orchestration tool where we can deploy those containers over the Google Kubernetes engine. Before we speak about the Kubernetes, let me just go back to the 2014, where people firstly heard the term Kubernetes. What is Kubernetes? How does it come in picture? So Kubernetes is simply developed by the 3 IT engineers who were working for Google as a summer project. So later that was joined by the Google and became a huge achievement for the Google specifically, and which later act as an open source tool, which Google hosted the first production grade version of the Kubernetes back in 2016. So since then they have released the minor version of Kubernetes. Each year they are releasing, currently it is 1.23 version which is in the market. So why does industry need Kubernetes? Let us understand with a very basic example, where I am running an application in my local system which is using the simple Nginx server, which is the 1.15 or any version of server I am using, and the same application code as well as the dependencies I am trying to upgrade or deploy over the production environment, where my application got crashed in the production deployment. Can anyone tell me the answer why it did so? So that might be the cause, because of the conflicts of the dependencies which my local system runs while it is missing in the production grade environment. So the dependency simply means that we are just installing the same piece of code over the production as well, but why it is failing over the production environment while it is working perfectly fine in my local system. That is because the different versions. My server was running on a version 2. Let's say for example my V1 version is running on a local system, and the same version which I am trying to install over the production environment has been missing. So that is the cost, but where my application got failed at the production environment. So here is the answer. That is Kubernetes comes in the picture. So let me just provide you this basic image picture which we are having currently at screen. So the whole thing starts from a Docker images. Docker image is nothing but a simple one box which contain my application code as well as the set of libraries and the dependencies which are necessary. So that Docker image which I can store in the GCR registry of the Google Container Registry, which is privately hosted registry provided by the Google. So where my those Docker images which I have built will be stored in the Google Container Registry. So from there on my images will be picked up and I will deploy that image over the Google Kubernetes engine. Google Kubernetes engine, which is fully managed or container orchestration service, which Google manages, and I just don't need to configure anything beyond. I don't want to manage the whole infrastructure manually. I want to scale my application down and up manually. Everything will be performed by the Google Kubernetes engine. So how does it work? So if you can look at here, at the broader means the Kubernetes starts with the cluster provisioning. The first thing we have to do in the Google Kubernetes engine is the provision of cluster. So that is the thing. Cluster contains the master node and the worker node. Master node is something which manages your whole whole deployment. Everything when we are applying over the Google Kubernetes engine will be applied over the master node, and the worker node will be the one which will contain the actual application or the microservices which I am going to deploy. So at the broader terms, it contains the cluster. At the upper, firstly we will create the cluster, then inside the cluster my nodes will reside. So nodes are simply, I would say, nothing but VM instances which will, virtual machines which will contain my pods, and those pods will contain the container where my the microservices are deployed. So that is the basic architecture we can say of the Google Kubernetes engine. So this is the pod.yaml file which we can use and apply at the master node of the Google Kubernetes engine. So if you can see here that we define the kind which we are using in the YAML file. That can be anything about pod or deployment or any service. So if you go beyond, in the specification section we have a section called image, which we previously talked about, the Docker image. So that image which will be used for the creation of those pod at the Docker at the Google Kubernetes engine. So I will apply the pod.yaml at the master node, and that master node will deploy those pod to my all worker nodes. So after pod comes the deployment file. So what is deployment? Deployment is nothing but the Kubernetes object which will actually help me to modify the pod which are deployed over those nodes of the Google Kubernetes engine. So how Kubernetes pick up the pod, which pod to modify. So that's we're gonna define at the selector level of the deployment file. If you all can see here, the level here is at the template section we have something called labels. So we will define the pod definition, and we will also use the replicas where how many copies of the pod I want in my Google Kubernetes engine node. That is the worker node. And all the files which we gonna create, YAML file which we deploy at the master component of the Kubernetes engine, and those files will be actually carried, like deployed over the different nodes of the Google Kubernetes engine. So, like after creation of the pod YAML or deployment file, how do I expose my application to the outer world? How my application will be accessed by the end user? How you guys or internet user can access my application? Like we will be deploying, like can you guys give me an answer? You guys all will be deploying one pod. So, okay, multiple pod will be there. How you can access your application? Because you will be having multiple pods. Your application needs one IP address to access your application which is deployed. So that's where the service will come in picture. Service will expose your application to the outer world. So I will like if you can see here the protocol which I am using or the port which my application is being exposed to, and the type of service which I have currently used in this YAML is the load balancer, which is a cloud provider service which will expose my application to the outer world and scale up or scale down according to the traffic it receives. There are different type of services as well. We can take an example of cluster IP or the node port service. So every service have their different use case. So let me just take you to the demo first. How do we actually create the cluster and how things work? So I will be working with the Cloud Shell here. I have used the command gcloud container create. This command to create a cluster at my Google Cloud platform, where the gcloud is the cloud SDK, where the container is the like gcloud is the cloud SDK I have used, and I am trying to create the cluster. The machine type of the cluster will be E2 medium machine type, because the N1 standard one is not being supported by won't be created using the I won't be able to create the cluster using the N1 standard machine type. And the zone which I will be deploying this application will be the US based 4C, and this will be the name of the cluster which we have created. So this is the cluster which is created. Just let me go through that. So after creation of cluster, I need to connect with the cluster. That is, I need to authenticate the cluster. So for authentication of cluster, I will be getting the command from the console of the Google Cloud platform. That will be this connect command. I will get the connect command from the GCP console, and I will run this command to authenticate my cluster which I have created. So yeah, my cluster has been properly authenticated. I have those automatic auto kubeconfig file has been generated by authenticating that cluster. Now after creation of the authentication of that cluster, I will actually create the deployment. So the command used for creation of deployment will be kubectl create deployment command, where the name of the deployment will be hello server, while the image I am using here, image which we talked about previously, about the Docker image, which is stored in the GCR registry of the Google services, private Docker services. I will be using that. So let's deploy that. So my deployment file has been created here. Okay. So once the deployment file has been created, you need to expose your application to the outer world so that your application will be accessed by the end user. So for that we will require the deployment we will require the service to expose our application to the outer world. So that service which will expose our application to the outer world, the command which we will be using will be the kubectl expose command, which will create the service. And the type which I have mentioned in the YAML as well here is the type load balancer, and the port which I am exposing my application to. So here the application will be exposed to the 8080 port. So my application has been exposed to the outer world successfully. Let's try to access that application. So in order to access that application which is deployed over that Google Kubernetes engine, we will be needing that static IP or external IP. So that static external IP is in the pending process because that takes some time to provision the external IP to that service which we have deployed. So let's try one more time. Here it will provision the external IP to that service which we have deployed. So let's copy that and try to access. So my application is been deployed over the Google Kubernetes engine right here. You can check out the Hello World application, the version I have used in my image, and the host name which is also configured in the code. I have provided the host name. This is my deployment name which I have used in my deployment file. So like I have exposed my application to the outer world. Now the application can be accessed. Okay, so this is the CI/CD pipeline which is used in the industry or which we can use to create a sample project. So here I am working with the GitHub. I will create a branch and I will be like all the developers works in a feature branch. So whenever any push or pull happens to that feature branch, a trigger will happen, and the cloud build service which is the used for building those Docker image. Using the cloud build, the Docker image will be built, which will contain my application code as well as the dependencies, and we will be storing that in the container registry and deploying to the Google Kubernetes engine. And I can also use the Terraform infrastructure as a code language to deploy things or provision resources in the Google Cloud platform. So and expose the service to the outer world by using the service which can be accessed by the end users, which can be you, me, or anyone who want to access that application over the internet. So that is all from my end. If you have any questions, then you may ask.
guide you how to get certified. Firstly, tell me, कितने लोग certification में interested हैं? Everyone? Yes. So why you want to get certified? Anyone can answer?
Career benefits.
Okay. Anyone else?
For creating a good profile.
Okay.
You
Exactly.
don't have to tell anybody you know this thing. The certification tells you.
Okay. You just like certificate will verify that you are skilled in particular technology. Is it? Am I right?
Yes.
Hello. So it's better now. So I am Mayur Rathi. As it has been informed, I work for Capgemini as a cloud consultant. Basically, I train people on cloud. Okay. I am here to guide you. We have seen lot of sessions on different services of GCP. But to get started on cloud, as you all are, maximum of you are in college, this is the best time. You would have ample of time. मेरे को पता है भोपाल के कॉलेजों में कुछ नहीं होता, ठीक है? This is the best time you should utilize to learn new skills, upskills yourself, get certified, showcase it in your resumes, and you would be having a good job in cloud and maybe any other technology also related to cloud. So I will guide you quickly why you should get certified. I have already informed you. So these are the main cloud providers which we have in the industry. GCP is amongst them. It has been a short journey for GCP. They are in the market since 2012, but they are seriously doing it since 2016. They are releasing lot of services every day. So architects at Google and the creators at Google are creating courses also for you guys. All of this is available free of cost. During pandemic also, they ran huge campaigns. I was part of Google Cloud through a vendor. I have seen internally how dedicated they are to upskill you guys. So they also partner with colleges to implement cloud career readiness programs. Okay. So check with your university. If it does not have, you may ask your faculty coordinators to apply for this program, and you can be leading this program within your colleges and universities. So why Google certified? So as I mentioned, this is amongst the leader of cloud providers within the industry. So let's see. As I also mentioned, it launches variety of services for your data, for your infrastructure. It have all sorts of services. Okay, you think and you would have unique services for that particular implementation. Now these are the certifications. Since we are running out of time, I will not get into details like how to get started. But if you see, Google recently launched this certificate, Cloud Digital Leader, which is again an entry-level certification. Even before going for the associate level, you may think of getting a digital leader certification. So I have given that myself. I have got couple of them as well. So it basically asks you about the understanding. You have a broad knowledge of cloud. What is cloud? How it is being utilized? So basic overview would be asked in this particular entry-level certification. And this is the other skill badges were recently launched by Google. So these are, if you cannot get a certification due to any of the reasons, okay, you can start by upskilling yourself on their cloud platform, which is Big Labs, also known as Cloud Skill Boost. Go there, complete the modules, which is also known as Quest. Once you do that, you would complete 4, 5, 6 labs on a particular topics. Once you do that, you would be earning these cool badges. You can also showcase this on your resumes. Are you getting?
Yes, sir.
So this can be a good starting point, and they run various campaigns throughout the year. You can utilize those campaigns to get free credits, subscription on this platform and get these cool badges. So this platform will give you a unique link that you can put on your resumes as well. Now, I have mentioned along with Cloud Skill Boost, there are 2-3 more platforms. These are called partner platforms. Through various campaigns, they also give access to these platforms. Okay, so if you are handy with these platforms, you can go there and learn about Google Cloud. Now, we within GDGs, we are also having this Road to Certification campaign going along. Scan this QR code, maybe click a picture. Okay, I will quickly show you how you can search for it. So if you go to this website gdg.community.dev, here we have our chapter page. Simply search for the Road to Certification campaign. If you scroll in the event type, just select this Road to Certification tag. Okay, is it clear? So if you select this, all the events which are linked to this campaign would be appearing on this screen. Once you join this event, what it does, whenever the event date would be nearing, you would be getting access to Cloud Skill Boost platform. Are you getting? So they will grant you 6-month access to that platform, and you can complete all those labs to get those cool skill badges. Okay, so this was one thing I wanted to mention. So this is the platform where you will be completing these labs. Okay, and once you complete, you would be getting the badges, you would be getting the unique public profile. So that's it from my side. Like, we will be also hosting a detailed session on how to get certified in the near future. Keep a look at your mailboxes, or also just ensure that you are joined our GDG Cloud Bhopal chapter. Okay, so you would be receiving all the notification in your mailboxes. And if you want us to collaborate with community at your organization or colleges or campuses, feel free to reach out to us. We will try to host a session for your audience specifically. Is it clear? Yes. Okay. So let's conclude. So now I want to talk about like how we hosted this. So we recently started this chapter in December month. Okay, I and Aditya were planning like how we can contribute to our hometown Bhopal, how we can like engage more audience, how to build a vibrant community. We are seeing, we are getting started with the startup ecosystem in Bhopal. So for that, we need a community as well. We reached out to Google and they allowed us, we created this chapter, and this is our third event in the city. So are you enjoying so far? Yes. Everyone? Yes. Okay. So this was like our first time hosting this event at the center of the city. I see there was a great excitement to join this event. We were not able to accommodate everyone, but for that we tried to get sessions to them through a live stream as well. Okay, so you can go back to your homes. If you were sleeping in any of the session, just you can check the sessions on the YouTube channel, which is again GDG Cloud Bhopal. Other thing I wanted to mention, we are available on all social media platforms with the username GDG Cloud Bhopal. Okay, on LinkedIn, Instagram, Twitter, Facebook, we have a group. Now, I would like to thank our speakers first. Like, it was a pleasure hosting them at this venue at Bhopal. Can you give a huge round of applause to them? Now, I would like to call my like co-founder Adit on stage. Like he was the pillar for this whole event. I was really busy with other engagements. He was like doing everything from scratch, like to how to build a team, how to get things done. He can share more in detail about like how he was able to do that. And I would also like to call my whole team on the stage. Can you guys come on the stage? So you must be seeing the familiar faces. These are the campus leads at all your institutions. So give a huge round of applause for them. I would like to call all our speakers again on the stage, and we can have a group photograph. Then we can quickly take a quick selfie, and later you can collect your swags at the registration desk, and we can conclude this event. Please come. And if you want to stay here for networking with speakers, with us, you can stay back and we will talk. Can we have a photo again with a victory signal? Even with after.
We are missing one person here. Prajwal, can you please? Thank you.
Thank you.
Can you all come here and we can take a selfie from here?
No. Maybe you click, they will come.
But we won't be there.
So volunteers, can you guys go this down?
Guys, 1 second. Let's take a photo and then leave.
Guys, can you all raise hands? Thank you.
Wait a second.
Guys, please